finale time, the finale month of grade -2 before we move to grade -3 of combo class. And in this state of transition, many things in my life have been going well. I have gotten past some personal problems that should make the future of combo class extra optimistic. However, I've been dealing with a lot of technological problems. I filmed a bunch of bonus footage for this channel that I wanted to put out. Since I did put out, make sure you have seen the extra long main episode I put out on my combo class channel recently. Until I release my final episode of grade -2 on there, a more documentary-like finale, which will require some new adventures and some new transitions around here. I have some bonus content filmed to release, but I filmed it on a new phone's camera, and there's something weird about the footage or how my computer reads it because the colors are getting messed up when I try and export it or even screenshot it. It's really weird, but like I'll screenshot a video that was taken on the new device and the screenshot looks bleached out, not like the actual footage looks. And then I do the same process on an older video and it doesn't do it. So I don't know, I'm figuring that out, but in the meantime, I figured, why not do a daytime live stream? A lot of the recent ones have been at night, so incorporate some other time zones availability. And today, we're going to look at some funner aspects of technology. For example, some different mathematical puzzle games, as I titled this. You could sort of say puzzles/games, because in a way, it's ambiguous if you would call some of these puzzles or games. Some of them are going to be ones that I have printed out to do like a Sudoku-like puzzle before. Other ones, you kind of need the computer to make it work. And I've never been much of a video gamer. As a kid, you know, I did enjoy playing some games and being like, what's the highest level I can beat on some random game? However, I never liked as much or cared as much about the little dexterity type of games where you have to be the fastest at clicking your keys in some certain way. I cared more about puzzle-based games, if anything, and especially now. I approach games sort of like the mathematician John Conway does, where you see them as little mathematical puzzles in idealized circumstances or simple rule sets to games. If one of the players may have a strategy to guarantee a win, or what will happen after indefinite amounts of time, or arbitrarily large finite amounts of time, or smaller finite sizes of time, what will you be left with? And, for example, the game chess ranges from being a two-person strategy game to being something you could have in puzzle form. Like I've seen puzzles of chess things before where you have a setup of a board and you're asked a question like, if you were white, which 3 moves could guarantee you can win with a checkmate? Now, here we're going to be looking at a few different types of puzzles to have fun with a few different types of games. And the first one, the first few we're going to do are on this site called mathisfun.com, which is a cool site combing through it. They have a lot of fun little resources of fun facts about numbers and stuff, as well as some games here. And the games that I've selected out of their list of puzzle games are ones that I thought looked particularly simple rule sets, so we can analyze what's really going on mathematically, but possibly complex enough behavior that they'll be tricky for me to try and solve. And there's 3 games I picked for that on this site, and then we're going to move to a different website for some sort of Sudoku-esque puzzles that I personally love, and that sometimes when I've needed to space out my mind and just work on something that's not a chore or a big goal or anything, one way I will do that will be to do certain little puzzles. And I'll show you some of my favorites of those in the second half of the stream. But to begin, we have one here, and the first comment on the stream denote says, have you considered getting a P.O. box so fans can send me old clocks? And yes, I had a P.O. box for a while, It is not, I believe, currently active, is why I took it out of the descriptions, but descriptions of videos for a while said, if you want to send clocks, here's an active P.O. box. And I did get some cool clocks and things from people, some of which we can probably see in the background if we look closely. And I will try and reopen a P.O. box for grade -3, because that was fun. And we have a fan of Math is Fun. I didn't really know this website until recently, but they seem quite cool. So I'm definitely going to say shout out to... Okay, they don't have the citation for this page, but shout out to... Oh man, I saw the guy's name somewhere. Some of these had citations on the pages. Oh, come on. Okay, these are the people on the team. Shout out to these people. And it's mostly maintained by Rod Pierce with contributions from many others. So, shout out to them because we're going to be playing some of their games. I think that in this world, with free use and fair use or whatever, that people should be able to use each other's resources, but that you should cite, when possible, who it is and give them credit. And, okay, I lost the page I was at originally. I guess that's a new page I opened, I'll hope. I don't think I lost one. So, here we have a first original puzzle game. And this game says, turn all the lights out if you can. Changing a light also changes the lights next to it. And I clicked around on this first puzzle, which is a pretty easy one. And what they mean by this is all of the ones that are orthogonally connected, or whatever that word is, you know, ones that are vertically or horizontally connected. And that means not diagonals, but if I click this, it should shut all those off. Clicking that should shut all those off. That was a very easy puzzle. But what about this? Now we have a weirder arrangement of shapes. And I might as well just make this pretty big because that's what we're looking at here. And what do we want to do here? Well, let's say we start with a corner. That should get those ones off. Now we have these two arrangements. What if we go inside one of them? Now we have this arrangement, and we should be able to clear them all. But the puzzles, I believe, are going to get harder, because when you look at options, you can see they have a list of 102 puzzles. That's a strange amount. It goes up to 102 at the bottom, actually. And presumably they get harder, or at least they're harder than, like, the first one was intentionally obvious, so you could see what the rules are. How about this? I'm not really sure how to approach this. So now if I go here, we have this shape, we have an H. This gives us two lines like that. If I re-click the same one twice, it'll just go back to how it was, so we have to click different ones each time if we want to make any changes. That makes that and that. Now we have this shape. Uh-oh, if I click this, we're going to be back to the beginning. Look, this is where we started. Somehow I cycled back. Let's try something else. Let's make a bunch of dots. And now let's try and clear the dots. Okay, now we have this. Now, oh no, how did we get back here again? Okay, it keeps cycling back to this one. So, none of these games we're going to be trying to beat every level. We're just going to be analyzing little potential strategies, which for this one, you know, I like how it keeps cycling back to this with seemingly different moves we're doing. But, let's see. Okay, now I have this. Will that help? What about this? Okay, this... Well, if I do this, we're going to have like a... Oh no, it's not quite a downshifted version. We'll have that. Oh, whoa. We have a square. The funny thing is, at certain stages, we're probably creating the original stage of some other levels. Some of the other puzzles probably, like... I wouldn't be surprised if one began like this, for example. So, what do we do here? Okay. Let's get it all down into the corners. Okay, now we have this. See, this is a very simple rule set for a game, but it has... Oh, we got it. But it has pretty complicated behavior. Success in 40 moves. I feel like they're roasting me with that. Like that they're implying that you probably could get a lot of lower moves. Okay, so let's just note that I was curious and I saw what the top puzzle looked like. And the top puzzle is all of them. It's everything is full. So I'm just going to click around this for a minute and answer a couple questions that have appeared in chat before we move on to our next puzzle. And one person notes that Math is Fun is also a good they have a good interactive article about triangle centers that somebody has used to teach geometry in the comments. Back where we started. So that's cool. I'll check that out sometime. And if it's interactive, maybe we'll even check it out on stream sometime. That could be fun. And now we have like an insect looking thing. Okay. And somebody says, can I give the link, please? I showed it a little earlier, but this one is mathisfun/games/allout.html. That up there. Now, if you want to find these, you can go to just Math is Fun's section about puzzle games. I think all of these were under puzzle games, or Games Index would definitely had all these somewhere under there. Now, a lot of you will probably just watch me play a few games today and then be like, oh, that was kind of cool. I learned a little and it looked kind of cool. But if any of them really catch your eye, then feel free to try them yourself. Like I said, some of the puzzles later I'll show are ones I'm already familiar with that I sometimes do for fun. Now, let's see. We've gotten this kind of small from all of them being filled. And, oh, one more comment that I wanted to answer is asking about my mathematical card game. I'm glad you asked. I actually brought just to show. So I'm developing 2 mathematical card games. One is a more long-term goal that is sort of more inspired by games like Magic the Gathering that has a much more complicated rule set and many more different cards, and hopefully would be something that once I start, I will be able to make future expansions that are combined into a greater whole of possibilities, like some of those games do. And the game that I'm beginning with, though, is a much simpler game, sort of approaching this type of puzzle game, where you're looking at how simple can you make a game and have a bunch of complexity. And so my game, which I might just call Numberations, because it's based around my ideas of numberations applied in sequence to change one number to another. This is a trial deck that I'm using to test which ones I want to include of numberations and how many of them I may want to include. And I'm not going to explain the rules to this one today, but I am going along with that, and I have begun working with someone graphic designing some of the cards even. So before too long, hopefully I will be able to make decks of those cards that I will try to give to my Patreon supporters and or just sell for cheap to whoever. And that'll be a very fun game. I think it's a simple one that would be... My goal with it, or a few goals, were make it follow what's called Zermelo's theorem. See my episode about Connect 4 if you're curious about that. Oh no, these are blowing away. Putting them back in a pocket. And to have it be simple rules but complicated strategy, and to have it be something both that you could play for fun with your friends and that could be a good classroom teaching tool. So that game I will keep you folks posted about as I design new versions of it, and if or when I want to describe the exact rule set that I have developed for it. So this game is pretty cool. I think I'm going to... Oh, we made a new formation we haven't seen yet. I think I'm going to wrap up with this game soon and move on to the others because, like I said, we're not really trying to beat every level on any one of these. Are we getting somewhere we've been before? We might be getting close to one we've solved before. but maybe not. I don't know. But soon at least, we're going to move on to the next game. And like I noted, we will be oh, squirrel. See the squirrel? Oh, it's way up there. It's hard to see. It already has a nut. My neighbor's been giving them tons. Now, the first 3 games we will be playing will be ones that I don't really have experience with the strategy of. And, oh, this is a simple enough formation. I feel like we could beat it from here somehow. This is a really simple formation now. I really feel like we could beat this somehow from here. Now, this one, I'll admit, I'm doing a bit of guessing. But if we were to analyze the strategy, essentially we have almost like a cellular automata-like state that we are allowed to pick which cell we are evolving instead of cellular automata would have every single cell follow this rule at each stage. And so we're sort of making like a one cell at a time cellular automata. Okay, so let's move on from this game. Oh, we made a little face there for a second, kind of. And the next one we're going to play is make the number. Well, actually, let's first do... These two are kind of similar. They're related to creating numbers. But first, we're going to start with Broken Calculator. It says Sam's... And if anyone wants the link to this one, there it is. It says, Sam's calculator got smashed, but some of it still works. Can you help Sam get the answers? And by answers, what they mean is there's some numbers on the side, and we want to make the calculator display each of these at some point. The C is to clear stuff, like on calculators usually. And on this level, what we have is a plus, a times, a 2, and a 3. And just to take a look, since there's only 6 levels, at what they look like, this one has a 2 and a 5 parentheses and a minus instead of a plus. This one has a minus and a square root of whatever's displayed there. And 1, 6, and 8. This one has 0 through 2 and that stuff. And it doesn't have a plus or minus for the first time. This one has these with a minus and a squared. And here a plus and a divided by and a squared, but just a 2. Now, the interesting thing is that I think they want the levels to get harder as we go, and maybe they do. I only tried level 1, which was pretty easy. But the thing is, I feel like the hardest would probably be the one that doesn't have a plus or a minus. Because the way this works, if you wanted to sort of hack the system and just get some answer without needing to care about how many steps it took you, well, I could just type in some really big number, and now I can do like, if it's not the right parity, meaning evenness or oddness of the number I want to get to, I minus 5 it, and now that switches its parity. And now I can just minus 2 until I get to the number. Minus 2, minus 2, minus 2. And eventually I could get to any of these. Some of them I would have... I mean, obviously, a lot of these I wouldn't have started at 255. I could have just started at, like, a much smaller thing like 25. But... or 2 times 5. But if we want to hack the system, any of the ones with a minus or a plus, we will basically be able to try and set the parity. Well, in this case, I was caring about the parity of evenness versus oddness because we had a 2. But in these other cases, if we have like a 1 in the mix, that's even easier. I can just make a big number and minus 1 until I get to each of these. So, like, this level is actually, since it doesn't say it cares about how many steps it takes, really easy. So we would almost, for these levels, want to rephrase the puzzle and be like, what's the minimum amount of steps it would take to make each of these? With that said, let's try the one that doesn't have any pluses or minuses. This one, we get 0, 1, and 2, and parentheses, but we only have times and divided by. We don't get that same easy option of make something tiny and add, or make something big and subtract, and just, hit your thing. Which, if we have a 1 in the mix, would be really easy with a plus or minus. 2 made it pretty easy as long as we could switch the parity somehow. And for 3, we would have to be able to get it to the right threvenness and such. But this one, to me, seems the most challenging or most interesting. So, why does it claim I'm partially done? I'm trying to do a new level. Reset it. Okay. Refresh. Oh, it still has all this in here. Whatever. Okay, there we go. Now it knows I haven't done any. Okay. So, let's try and build some of these. Well, we can't just do 1 plus 2. We don't have a plus. So, I can... 10 divided by 2 will get my 5. So we got... Oh, and it got 10 on the way. Now, this one's also kind of cool because our target numbers are basically like all consecutive numbers right after the ones that we have. 3 through 10. And the other ones were like easier to use tools with their plus and minus, but much more random looking target numbers. This to me is more interesting. Like if we wanted to extend this, we would say, well, next, what about 11? So let's try and get some others. How about 12 divided by 2 to get us 6? And then we can divide by 2 that to hit 3. All right, we got a bunch there. Now, what about... Now it gets trickier. So, I want to do like 21, but then I can't divide by a 3 or 7 without creating the 3 or 7. And so we can create a 3 in parentheses. That'll take a while, but we can do it. So 21 divided by, in parentheses, our way of making 3 was 12 over 2 and then over another 2. And that's given us 7. So we got 7 there. Can 7 help us get any others? Let's see. Well, if I can make 7 up to 42 by... Yeah, so 7 times... I want to get 7 to 42, and so I want to multiply by 6, which was 12 over 2. So now I'm at 42. And now I can do this tricky thing. Divided by 21. And now we're at 2. And while that doesn't look like it helps us, because 2's not in the mix, now I can multiply by 2 to hit my 4, and again to hit my 8. So, now we're just left with 9. How are we going to get our 9? Should we keep the 8 or should we clear it? Let's keep it. It could be useful. So let's see. Let's go back down to 4, how about? And then we're going to... Let's see. If we multiply by 12, we're at 48. And now I can divide by 2. That's not necessarily helping yet, but let's see. 12... No, we've been here. We built 12 way easier than this. Okay, let's restart. Now we just need to get our 9. How are we going to do this? So, we're going to do... What? Time's up? I didn't know I was being timed. You got to tell me this math is fun. Tell me Sam is taking a timed test. Okay. I feel like we did pretty good, though. We got 7 out of 8 of the values. So, leave a comment if you can figure out a good, nice, simple way for us to have reached 9. Now, let's move on to another game, because we got plenty of them to show. And the next one is kind of similar to this. We are trying to create numbers. This one's called Make the Number, and here's the link. And for Make the Number, what we're trying to do is... Now, this one's interesting. The way it does it, I fiddled with this for a second, and it has a bunch of options, and it randomly generates, using these options, the game. Then the computer says if it has calculated it or not, if it had an exact match or not. And some of them, I did one that the computer said 1 off, and I think that means they were only able to get a number within 1 of it or something. So this one does say computer has exact match. The thing is, the presets are kind of weird. It's because these are the numbers we're allowed to use. And we're trying to use these. Can we use them more than once? Yeah, we can use, wait, it says 2x. Does that mean I'm not allowed to do that? Am I not allowed to do them twice? Well, let's try and do it with using them only once. And we can use this calculator thingy, I guess. But wait, how do we... I guess I don't type them. Why does the calculator have numbers if I'm not allowed to type them? If I'm supposed to use these things? I can't tell if this means that I'm not supposed to have done 2 twice or not. But in any case, it's kind of random presets for which numbers were given up there. 4 from 1 through 9, none from 10 through 100, except for 2 that are specifically these values of 10 through 100. So that seems kind of weird. So why don't we... I don't need any of that specificness. Let's switch it so we get 2 random ones from 10 to 100. That'll make it much more challenging. So now let's do new game and see if computer got... Yeah, the computer got a match. So 534, this doesn't sound easy. My thought is we want to use these big numbers to try and get close to it and then use these little ones to balance it out. So, like, for example, if I did 10 times 90 divided by 2, that would give me 450, which is kind of close, but not that close. How can we get closer than that? Well, let's see. If I wanted to combine these, let's think also about how many times larger is 90 than some of these, in case we wanted to do 90 divided by that. Like 90 divided by 6, we get 15. Divided by 4, we get not a multiple. And divided by 2, 45, or 9. But using just those, it's hard to get that big number. So, you know what? I think we need more big numbers. We're gonna have 3 small ones, and we're gonna do one of these specific type. And now we're gonna generate a new list. 997. Wow. So the computer is searching if it has an answer or not. It's taking the computer a while on this one. This one seems easier almost if we can get to 1,000 and then find a way to subtract 3. So the computer's taking a long time here. What does best so far 1 mean? If that means you've gotten 1 match, then just tell me you got 1. 1 off. No. See, what does 1 off mean? Let's see. 100 times, this would make 90. So that's 9,000 divided by 9 is 1,000 minus 4. Yeah, that's 996. So they were 1 off of the number. So let's make a new one because I want there to be an answer. So the computer got a match on this one. So 778. How are we going to approach this? Can we get to 780 then subtract 2? What is 780 a multiple of? Let's think. Let's split that in half. Gives us 390. And if we split it in half again, 390 gives us 195. So if we can make 4 195s, let's see. This is maybe I should have gone with their thing where they give me more generic values. Or we got kind of lucky. These are kind of round values. So I'm going to only investigate this one for a minute before I move on to some puzzles that I have more experience of what strategy we should use. But I like little mathematical games like this. And the simpler, the better. This one's kind of random because you're just getting this random set of numbers and a random target. But if you imagined a game like this where you got like the first n amount of positive integers here each once, and then up here you got, you know, some specific types of target number, you could create some interesting like generalized puzzles. So I think I'm going to leave this one up to the comments because I don't want to over focus on this and then maybe not even get the thing the computer got. in a moment, we're going to move onward to some Sudoku-like puzzles, but I don't even know if I'll do Sudoku itself today, ones that are similar-esque to that, in that I have done printed out forms of them before. In fact, they show up in some newspapers, some of these. And first, for a brief little tangent, I do need to show you folks something fun that relates to last stream. This isn't mathematical, but bear with me. So last stream, I was talking about how hyped I was about this dehydrator that my family got, where we got a dehydrator device that's not that big and not that expensive, that you just like plug in and put thin-ish sliced fruits or stuff. I've only tested fruits, and dry them. And we originally got it for extra apples and pears that fall in this shared yard that we have with some other families, and not enough people eat as many apples and pears as there are. So we were like, we'll dry them. But then I got hooked on drying random different fruits from the supermarket and just going to a grocery store and going, like, the local place I get produce from has a back room with really cheap stuff that sometimes is going moldy, but if you dig around, you can find some that aren't, that are just like either overstocked or gonna go moldy in a day or two, but not yet. And if they're, you know, or maybe they're a little bruised or something, and those work just fine for dehydrating. So, for example, when I was there yesterday, I got 2 giant things of strawberries for $1 each. And unfortunately, I can't show you a dried strawberry. I have some other ones to show, because the strawberries were so good, I ate all of them before I remembered to set any aside. Same with the peaches. I ate all the peaches before I set any aside. However, I do have some that I set a copy of them aside to show you folks. And you really can do this with like any fruit I have found. Different ones have different amounts of time you want to do them. Like, you get to a soft stage where they taste sort of like they would in a pie. And then you get to like a chewy stage. Then you get to like a not as good in between stage. Then you get to a kind of crunchy stage. Some of them are better at the chewy stage, and some are better at waiting long enough for the crunchy stage. But some work at any stage. Here are a few. I've shown this type before, which is a banana. Those work very well and simple for however long you want to do them. And here's some little pieces of a white nectarine. I also tried yellow nectarines, were quite good as well. I got to do this next time I go on like a hike or adventure or camping or something, because if I dehydrate them long enough, they'll stay fresh for a while. I mean, they won't go bad for a long time. Here, I have a piece of a pluot, which is, as you may know, sort of a hybrid between a plum and an apricot. The technical name for this type might be an aprium, which the terms are weird. Pluot has like one brand, I think, that started that term. So aprium may be the more official but less used term. And here is mango. Now, I don't know if any of you have tried dried mango, but it tastes exactly like it would out of the bag for like 4 times cheaper when you get a mango and you dry it. So these are all so good. I'm going to eat a few of these while I take a quick look at our comments to see 1 or 2 to answer, and then we'll pull open our next puzzles. Okay. One comment noted that they would have done the same with the strawberries and the peaches, and if they had the mangoes, and trust me, it was hard to set aside this mango and not eat it. I'll eat it when I need a break in a minute. So, to move on to some other sorts of games, somebody asked, are there any anti-magic or hetero-magic squares for 3x3 squares that could fill a Sudoku puzzle? And I'm not sure, I haven't looked into that, but it's a very interesting question. There could be an episode about Sudoku someday because it has a lot of strategy behind it. And to jump into this, let me tell you a little story, which is that I remember being on a camping trip when I was younger, and I didn't have like technology. I don't even think I had technology apart from being on a camping trip, but especially if I was on a camping trip. And so the only like, digital-esque things I had were like books and notebooks and stuff, and newspapers that we would sometimes take a walk to get, the daily newspaper. We would take like a hike and get it. And so with the daily newspapers of the local, whatever the local one was over there, they had Sudokus in them, and I wasn't used to seeing that. I didn't know them yet. So I had to sort of figure out the strategy from scratch myself. And I had a ton of fun and went down this little rabbit hole of them. And it was one of many times when I was younger where I had some little hobby for a while that I didn't connect necessarily with loving math. But looking back on it, a lot of them had that in common. It was like, okay, I like Sudokus and Rubik's Cubes and logic puzzles and stuff. These have something in common. Now, with the Sudokus, that's not the exact type I'm going to show today, because I've had that feeling again a few times where I see a puzzle I haven't seen before with simple enough rules that I can sort of start from the beginning in my head and be like, what would the strategy be? How do you approach this? And some of them I've fallen in love with. And the one I have the most is probably this one that is sometimes called Two Not Touch and sometimes called Star Battle. The guy who makes this site we are moving to is crazydad.com, and he has a very good batch of puzzles he designs. And I read somewhere that he designed the Two Not Touches mathematically, like he had a formula to calculate all the arrangements of these that could fit the stars in the allowed way and such. And I've often printed them and done them with pen and paper like that. And he does have a tutorial here, but I didn't look them up at first. I saw these in the newspaper one time. They showed up in a newspaper that I had there, and I hadn't seen the puzzles before. And that was because he had gotten them in the New York Times for the first time. And now they are published in there, I think. And these are the 2-star versions. There are 3-star or 1-star versions. But with the 2-star versions, the way it works is really simple. It's sort of Sudoku-esque, but it's geometric. And the only rules are there are going to be a 10 by 10 grid with 10 enclosed regions. Each line, either horizontal or vertical, not diagonal, doesn't have to be counted. Each horizontal or vertical line must contain exactly 2 stars. And each region must contain exactly 2 stars. And you can't have any 2 stars touching, including diagonals. So you can't have any stars in the neighborhood of each other. So I saw this in the paper one day just with those instructions, and I was like, wow, how do you even approach that? What strategy would you want to use? And the first thing I realized was, oh, it would be really helpful to mark the spots that you know there's not a star. Because looking at this, you're like, I don't know where stars are, but maybe I can figure out some spots that couldn't have a star. So to see an example of that, let me first run through a pretty simple one. Okay, so to pick a random one, I already know like how his books of them work, because I've done a lot of them, but not nearly all of the ones he's designed. But why don't one of you who's watching this live comment a series of 3 numbers separated by commas. The first is a whole number from 1 to 5. The next is from 1 to 100. And the next is from 1 to 24. Sounds random, but that's because he has 5 volumes worth of puzzles of the 2-star ones. There's 100 levels. So I'll give you the spoiler that 100's the hardest level. But, pick whatever level you want to see. I can solve them really good. And he has a tutorial that I know a few techniques he didn't list in the tutorial. And he wrote somewhere that there are some puzzles he has to do a sort of guess and check process. There are none of them that I have to do that with now that I've developed these extra techniques that maybe even Crazy Dad himself doesn't know. So I'm going to contact Crazy Dad sometime, because I love this puzzle enough that someday I'm going to make a whole episode about it. And I need to interview Crazy Dad for that episode. And I also need to make sure that he knows this one strategy, or a couple strategies that I know that aren't in his tutorial. Now, There's printable star battles, which are my favorite way to do them. But, you know, if you're in a mood to do a lot of them one week, you might not have enough ink and paper. So there's the online star battles. And somebody said 46418. Someone else said 111. So I'm going to do the two of those, but I'm going to start with 111 because that's it starts on 111 if you pull it up. You can now I can pick them if I want here. These are what I meant. This is the first number, second number, third number. And this is just what type of puzzle. 1 star on a smaller grid, 2 star here, or the rarer 3 star on a bigger grid. And with these, we'll start with 111 because it's going to be easy enough that this one I'll explain my thought process while I'm doing it. When I do a harder one, if you want to see like a really hard one, I might try and zip through it and not explain my thought process because it tells you how long it's been that you've been doing it. And I used to time myself when I did the paper ones, and I like seeing how fast I could do the hardest level. And I can do them pretty dang fast, folks. If they make a 2-knot touch tournament someday, I have a good chance at being the 2-knot touch world champion. I still need to refresh some of my skills because it's been a minute. But when I did these a lot, I could whip through the hardest level. And there's a lot of crazy techniques you got to use. But let's begin with 1. Wait, this is so weird. I'm pressing Command minus. It should be shrinking it, not growing it. What? Maybe I have that backwards. This is weird, though. What? Now it gets blurry when it's small? What? Okay. I just want to make a size that fits on the screen next to me. Okay. Star Battle's going over here. And there we go. We'll just put a random that in the background. Now, how would I approach this? Well, you can make crazy dad like me, came to the conclusion that you want to be able to mark which ones aren't stars. So there's 3 states. I don't know. Not is a dot, or star is I know there's one there. Now, when I do these on paper, I have an extra step that isn't allowed in the programming where sometimes I draw a line down the middle of a region if I know that one of the 2 stars in that region is on one portion and the other's on the other portion. That comes in handy visually when you're cutting stuff down, but we can't do that here, so we have to imagine the lines. Now, to begin with, we can note that certain shapes must have certain properties. Like this shape right here, with these 3, it has to have the stars on the end if we have 2 stars that are not touching. But even if I didn't know that one, because that's going to make it really easy, it's going to wipe out a lot of stuff. I would start, if I'm trying to go fast, with that, and then I'd be like, none of those are it because they're touching it. None of those are it because they're touching that. And we've used up the ones in this line, so now none of those are it. And now this one's become obvious from that. But even if I hadn't known that, this is one of those shapes I would have known certain things about. Imagine I didn't even know these 3. Well, I can't have one here because that would eliminate all these. They're touching it. And then this region would only have room for 1. So I know it can't be there. Now, similarly, I could do other techniques like this line. What's left right there? We have a 1 in a row and a 3 in a row. And so we could either have 1 there and 1 of those 3, or we could have none there and 2 of those 3 on the ends of it. But either way, I can't have this one below that line because this would eliminate those 3 and only leave room for 1 star in the line. Now, I do have those, so I do know that it cuts off those. So it's going to be those 2. We can also now eliminate the regions around those. This is the first level. So it's one of the ones he deemed the easiest. Now, in this shape, this is a good example of something. Pretend I didn't know this one. That one's even easier. But pretend I just had this. Now that that's eliminated, we have a 2x3. Well, it can't be either of the middle ones because this would eliminate the rest of them and only leave room for that being the only star in the zone. Same with that. Would eliminate the rest of the zone. And so it has to be 1 within those 2 and 1 within those 2. Now, whenever I know there's a 2 in a row, where not a 2 in a row, but I mean two cells in a row that must contain one star, the neighbors get eliminated of those because the neighbor would kill both of them. By killing one of them, what I mean is eliminating too many things as possibilities. So this right here, similarly, its neighbors would kill too much. So they're dead instead. Now, YouTube, don't censor it. We're talking about dots. Okay. Now, what do we know right here? Just to go kind of quicker, this has reduced that to that region. So we'll just go with that knowledge and know that helps us really quick. We eliminate them and they're in a line, so we eliminate those. Now, here I can see that this line has one star in it. So now we're left with a 3 in a row. There must be one within one of those 3. And you know how I said when there's a 2 in a row, both of the neighbors get eliminated? When there's a 3 in a row, where one of those 3 must contain a star, the middle neighbors get eliminated, because those would be the ones that would eliminate too much. And here, this region's become pretty simple. We know it can't be these middle ones, because those would, only have room for them to be the only star. It's got to be those ones. So, what do we know now? Well, there's some other strategies we can employ. For example, what if I look at the bottom 2 here? The bottom 2 rows. Well, in the bottom 2 rows, there should be 4 stars worth, because 2 rows should each have 2 stars. So in these bottom 2, we have 1 right there. And this zone, which is fully contained, must have exactly 2. That leaves us needing our 4th star. So this has to be 1. So now there is 2 somewhere in here, but that zone's big enough. We'll target a smaller zone first. Like this. This has already become so eliminated that we know what's left. Those create a line. Whenever 2 create a line, we can sort of eliminate what's there. Now, this level, like I said, is what he deemed the easiest. And so we'll try the harder number set someone left in a minute, and that will show a lot of other strategies we're going to have to employ. Here, even without a lot of the strategies I said, it may have been pretty obvious to solve this puzzle. That eliminates those lines. That must be there. That must be there because of the line. That must be there because of the region. Now, that can't be that. Here, we only get 1 in there, and this region must contain 2, so we need 1 there. Or we could have judged that by this line, having only that left. We have that now. So we need 2 within here. It can't be there. It could be one of these, but this has to be there. So that leaves that. That leaves that. That eliminates that and leaves that. And the stars danced because I got it right. And they tell you how long it took. Now, here's the problem with that. I think it begins counting from your first click. And so if I spend longer thinking about it before I first click, I get like an unfair head start. In a tournament setting, if you were to do that, you can't give people unlimited time to study it before you do it. Because with unlimited time, I could figure out where the stars were, and then it would be a who draws the stars fastest contest. So, I mean, who of the people who can calculate it in their head with unlimited time draws the stars the fastest? So, when I do these and I want to time them, I'm like looking away, I start the puzzle, and as soon as I look at it, I try and click a dot on a really obvious spot. And then I know that I'm timing myself fairly. So now let's try the harder level somebody mentioned. And that was 464.18. If anyone else is watching live, feel free to comment a third one where the second number is something even higher than 64. And then we can try an extra challenging one. This will be on the more challenging end. Crazy Dad wrote that the newspaper ones he prints are only the first 30-something books, which are basically levels. Volumes are like whole new sets of them. Books are like levels, and puzzles are within that level, different options. So only the first like 30-something get printed in the newspaper. So already with 64, we're doing one that was deemed harder than what they put in the newspaper. So that's okay. We know many strategies, or I do, and maybe anyone watching carefully is figuring some out. Leave a comment if you can figure out how you would phrase any strategies, either that I mentioned or that I haven't mentioned yet. So let's search up this puzzle. And like I said, I'm not going to look at it very closely until I click an obvious one, because I want to time it fairly. No, I'm not going to. I'll explain what I'm doing. I won't go for a speed win. I will explain what I'm doing. So somebody recommended another website. I will check out another website, but we have enough on our plate for today's stream. So I will check out any cool links people recommend later on my own time and maybe incorporate them into a later stream. So let's search this. Hedgehog. Now, what do we know? Well, I'm going to first do something where I target regions that I know something's going on. Now, in a square of a 2x2, you can only fit up to 1, and that tells us a lot. So, for example, this region must have 1 in that square and 1 in those two, which means, remember, when we have 1 and 2, we eliminate the neighbors. Similarly, this region must have 1 within those 3. That's in paper where I draw a line. So it eliminates that, and these eliminate those. And a really important thing to remember is that thought. This is sort of the core of one of the things that helps me that isn't in the tutorial, is related to the fact that a square can contain only up to 1. So now these ones are really obvious because of that. Because if the square can only contain up to 1, it has to have another one in there, which eliminates that. Then we have a 2 in a row, which eliminates those. But wait, we can now employ another technique. If we look at the bottom 2 rows, there's 2 regions fully in there. If there's ever an amount of regions fully within an amount of rows, that the amount of regions is the same as the amount of rows, they have to use up all of the stars, basically. We need 2 there, we need 2 there, and there's gonna be 4 total in those bottom 2, so we can't have any in the other space that isn't those regions. Sometimes I also think about that backwards when I'm trying to scan the puzzle, and I might have noticed, hey, look, 1, 2, 3, 4, 5, 6, 7, 8 different regions here, if these weren't whited out, are the only things in a zone. It's like the opposite of there's other stuff, but these are fully enclosed. It's like they're not fully enclosed, but there's no other stuff. So then I could have looked at it reverse to do that as well. Are there any other examples of that here? Because that is something we want to scan for very quickly, because it helps us greatly when we're trying to do the puzzle. That's my second step I employ after targeting obvious zones. But if I see another obvious zone like here, I now have a shape left that must eliminate that, since we can fit only up to 1 in that square, and only up to 1 in that square, and we need 2 with that stuff, so it's not that. Now, let's look at my other square technique that I employ sometimes. This isn't going to tell us any information yet, but it's pretty cool. So these 4, I notice, create a square on the edge. And so what that means is there's only 4 squares worth left. Meaning each of those squares worth must contain exactly 1. Because we need 4 in these 2 columns, and there's only room for up to 1, up to 1, up to 1, up to 1, so it has to be exactly 1 in each of those cases. So that's harder to remember or to draw here, but we know that this square contains exactly 1, this square contains exactly 1. We already knew that that contained exactly 1, but now we know this little region contains exactly 1 of those 2 as well. Now, from there, let's just do some obvious stuff. Well, actually, I want to show that technique because it's fun. We do have 6 regions also enclosed in 6. 1, 2, 3, 4, 5, 6 are all enclosed within the bottom 6 rows, so must be eliminated. Now, here we get an obvious one. We had these 2 stars in a row, so we get a line, so we get these. That makes this pretty obvious. This, well, not quite. We need 1 within those 2 and 1 within those 2. So that's not cracked yet. However, we do know that these 2 rows will only fit 4. So we know we have 2 there, and then we can sort of justify that between this little sliver, that, and that, we have 2. Not that that necessarily helps us yet. However, this helps us. Look at this. In this zone, this must have at least 1. It can't have 0 because this isn't enough to fit the other 2. So this must then have exactly 1 because there's already a star in that line. We can't have 2 there. We'd have 3 stars in the line. So that means there's exactly 1 there and exactly 1 within these 3. Now, if there's exactly 1 in these 3, that's basically the same effect as having 2 stars in a line. Because look, they're all in line with this star. So if one of these is a star and that's a star, it eliminates all those. So there's this whole batch of techniques we're going to want to use when strategizing here. Here I get a shape left like this thing. Can't be that because that would eliminate too much of that. Now, here we can look for other simple things to see if anything obvious pops out first. And if nothing obvious pops out, we're going to look for some other strategies. Like now, coming back to this square technique I did before that didn't really help us before. It's going to help us this time. Well, in these 2 columns, that can only fit up to 1, that square. That square can only fit up to 1. That square we know has exactly 1. And that leaves room for that needing to contain exactly the 4th. So that must be there. And we knew we had 1 in that zone. Now, let's see what else we can deduce. Well, from here, we sometimes want to also look for lines that are mostly full. Like here, we have a lot of dots of eliminated ones in a row, and that ends up telling me, well, with this space left that's 4 in a row, if we need 2 within that, well, it eliminates those. And we can also see it as 2 little 2 in a row things that eliminate their neighbors. So those 2 cover that row. And here we have 5 in a row that we must have 2 of exactly. Which normally if I didn't know anything about these, like even if I didn't know that and that were eliminated, those end up being the points you can eliminate on a 5 in a row that you know contains 2, or like these certain things surrounding it in certain spots. Now, what can we deduce from here now? Well, let's see about other zones that exist. Up here, we have a pretty small zone here. We can't have it be this neighbor to it because that would eliminate too much of it. So that's gone. That means that in this zone, we have that circumstance where we had that P-like shape, the one that they call the P pentomino. And we know it has an end there, and we know we have one of those too. Now we have a shape where whenever we have a shape that fits within a 3x3, and that's the whole region, it can't be the middle, because that would eliminate too much. So let's see what we know now. Well, this 4 in a row helps us less because it only contains 1. We already had a star in that line. But now I'm sort of scanning for zones that are pretty full. For example, this column must have 1 there and 1 there. That eliminates those, and this does eliminate the neighbors of that. And now I know this, let's see. Well, that's almost fully eliminated, but it could be either of those for now. This zone, though, got pretty small. Can't be the middle. Can't be that one either. Has to be those 2. So now we eliminate those, and that leaves us with this having a 3 in a row that must just have those. Eliminating those tells us that this is all that's left in that column. Now here we have a 3 in a row that must contain 1. We get to eliminate one of the neighbors that would eliminate too much. Not sure if that was greatly helpful, but why not? This must have a star for that column. This must have a star for that column. And eventually you hit a breaking point where you can fill them in pretty quick because you've gotten past a certain amount of info where it's almost like doing it for yourself just by doing the basic checks. I know there's one there and one there. That eliminates those neighbors. Let's see. We have 1, 2, 3. Oh, this is all that's left in that zone, so it has to be there. So this has to be those ones. And that eliminates that, leaving us with this and this. And they danced because we got it. Okay. So, as Wade noted in the comments, that he's glad he saw the puzzle because it's very simple rules with such interesting consequences. And totally true. It is really fun. And in fact, let's try one with a much higher level to see a really hard one that I'm just going to go through pretty quick. And well, okay, we'll do 2 higher level ones. We'll do one first where I explain it, and then one where I just see how fast I can go. And when I'm seeing how fast I can go, try and figure out what I'm doing. Because, you know, hopefully it'll be the same techniques I've had a chance to explain, but there's many sub-techniques that you learn when you mess around with this. So let's try a pretty high book number, but I was playing around with the level hundreds the other day, and I don't want them too fresh in my memory. So let's try something random near that. Let's do like level 97. And we'll do a puzzle somewhere from 1 to 24. Just in case I did the first few puzzles, we'll start from puzzle 5. And we'll go down a volume. So this will be a pretty random one of the hardest puzzles as deemed by Crazy Dad. And, I mean, how hard they are is subjective. But everyone on the site here has exactly one solution. That's what's important to games like this, is you can't have 0 solutions, you can't have multiple. When you're designing the puzzle, you need exactly one solution. And if there is only one solution, there should be some strategy to be able to figure that out. Some puzzles may require more guess and check, but with Do Not Touch, you don't really need that when you learn enough techniques. So let's see what this one looks like. Okay, so to explain how I'm approaching this. First, I'm targeting some regions that give me obvious eliminated neighbors. This must be 1 and 1, so it eliminates these neighbors. This one does similar. That would eat too much of that. That would eat too much of that. That would also eat too much of that, because I need room for 2 in each of them. This one gives me a lot of info. What else is obvious? I don't know what if there's other obvious ones here. So now we're going to jump to the next technique. Now we're going to look scanning first. I like to scan each of the 4 ways really quickly, but if you inverted the process in your head, you could theoretically just scan two, like 1 of the horizontal ways and 1 of the vertical ways. But I find it easier to do both and just look at it one way. And we're looking for fitting a certain amount of shapes within that amount of rows or columns. So 1 doesn't just contain 1, 2 doesn't just contain 2, 3 doesn't just contain 3. Going up here, we're not seeing any. So now I'm going to look from the other way. 1, 2, 3, 4, 5. Not quite fit in 5, and not quite in 6. So didn't really get much data from that. And I do this as a pretty quick scan to start, because usually you can find something or another that gives you some info. But this one, you know, could be an exception. There are certainly exceptions. Let's look at this direction. 1, 2, 3, 4. Those fit in 5. This almost fits in 5, but not quite. Almost fits in 6. So that technique doesn't actually quite help us yet. Usually you can find some right off the bat where you sort of skim one direction, then skim the other, and it helps, but not always. So let's think a little deeper. Here we know that we have, let's see, let's look at these 3. These 3 to the right of columns contain at least 1 to 2 in that zone, 2 there and 2 there. So we have 0 to 1 in that zone, and we have 1 to 2 in that zone. Not sure if that necessarily helps us yet. Oh, here, this will help us this direction. The bottom 3 rows, This contains 2, that contains 2. And if we look at these shapes, we can see that that must contain exactly 1, and that must contain exactly 1. So that actually takes up together, like that's half of a region worth, and that's half a region worth, and these are each a region worth, eliminates these in the bottom 3. So it was basically that strategy I was discussing, which would have been a little more obvious if I was allowed to draw lines in the middle of these, but just, you have to try and remember in the digital version where your shapes are cut off. Now, what else do we know here? We've now eliminated some there, so how could that help us? Well, this shape got a little smaller, but that was one of the biggest shapes, so that's one of the harder ones to get help from. Now, where should we go next from here? Well, moving this direction. Let's see. Yeah, some of the higher levels require a bit of thinking. And if we go... I'm trying to imagine... Okay, here's a consequence. We need at least 1 in here, in this part of this region. And we need at least 1 in here, in this part of this region. And remember, when we have 2 at least ones in a line, column, or region, they must be exactly ones. So we have exactly 1 in each of those bits, meaning that's not it. Also meaning we did have exactly 1 in there, eliminating the neighbors. And we did have exactly 1 in there, eliminating that little neighbor. Now this region's small enough, its center can't be the 1, so that gets eliminated as well. Now, here what else do we know? We've now shown there's 1 there, 1 there, and that means that there are 2 between that and that, which isn't enough information yet. So let's look for some other clues. Well, here I see 2 side things. This is kind of like when we saw a square on the side and we could build from it and be like, only so much fits left in that 2-row stretch. We actually get a similar effect when you have 2 blocked off on each end. It makes a square-like thing where we do have only 4 squares worth left in this 2-row set, and each of these squares must contain exactly 1. So there must be 1 there, 1 there as we knew. Now we know that there must be 1 in that square and 1 in that square. That doesn't actually help us eliminate anything yet, but it could be useful information. Now, let's see what other consequences we can find or develop here. Oh, this is one that popped out. Now that that's eliminated, it's got to be that one. So we've got our first star, and that will really help us start to get a ripple effect going with these. We still know there's 1 in those 4, but that's not quite enough info yet. We do know in this one it's getting pretty full. So unless it's those 2, it's probably one of those 2, but not necessarily, because it could be those 2. Now, let's see. This row is also getting... Oh, that gets eliminated. That helps a bunch, because now that that's eliminated, these 2 columns are fully taken up by these 2 shapes. So everything else can't exist in there. Now I have a 4 in a row that must contain 2, so all the neighbors get eliminated. Now, what do we have? We've shrunk a lot of things. How can this help us? Well, this region really shrunk. It's got to be those 2. Now, this region's small enough. It can't be that center one. Now, let's look here. We have at least 1, but could be 2. 1, 1. Can't guarantee that. We do know it's one of those 2, so it can't be that. Now, this one's getting kind of clear. This 3 in a row, we can't eliminate all of it because we can't fit 2 there. So it can't be these, like, middle neighbors to that 3 in a row. Now, where are we going to go from here? Now, let's see. Oh, we can use those corners get eliminated, meaning it has to be that. Sometimes it's the obvious ones I miss, where when I'm scanning through, I'm looking for harder stuff, and it's like, oh, I didn't eliminate a corner. So we know that these 3 must contain 2 because of the column. So all that gets guaranteed. Now, I did a quick scan for 2 in a rows going this way I could eliminate. We don't have any 2 in a rows, but we can see which ones don't have much room left. Sometimes helps. All right, now how about down here? This must contain at least one. This must contain at least one because of what's left in their shapes, meaning they each contain exactly one. So we could have deduced that also by being like, in these two, we have 1, 1, 1, 1. So since we have 1 within those two, mixed with that star, it eliminates that one. So we have 1 there and 1 there. This tells us in these two columns, we could only fit 1, 2, 3, 4. So this is guaranteed. So now we have 1 in there and 1 in the rest of that region. And what else have we been able to shrink? Well, I can't have 1 here now because if I had that, all of these would get eliminated, leaving only these 2 in the region, which would form a line and eliminate too much of this region up here. Now, this one must contain at least 1 in that row, mixed with that star means exactly 1 in there, and must have 1 in there. Now, here, where can we go next? I'm looking for ones that are mostly filled up, that might be able to just be 1 clue away from being correct. Well, here we have an interesting example of my square pattern, where seeing that square, I'm like, what can we eliminate? Knowing these 2 columns contain that missing, and 1 there, we just have room for 3 other ones having to fit in 1, 2, 3 in there. So we need 2 in here, so it can't be the middle one. It must be 1 of those, and it must be 1 of those, and those are both in this region, so it can't be those ones in the region. So we are close to eliminating a lot of stuff. And where can we go from here? So, looking for regions that have, or rows or columns that have a lot full. This one is now pretty full, and that had to be there to fit, and 1 has to be there to fit. Now, this region needs 1 there. Now we need 1 there, and we may have hit our breaking point, or be close to it, where they sort of fall into place. Just using the simple types of deductions, not the complicated strategies. So here 1, 1 eliminates that. 1, 1, 1, 2, 3, 4. Okay, in these 2 columns, we have to fit 1, because that's actually eliminated from that corner. So we can only fit 1, 2, 3, 4. That had to be there. Now we can note that here, that's the only one left in that, in that column. That's the only one left in that column. And we are basically at our breaking point, where the rest of them just sort of fall into place. Yay, we got it. Now, these are taking a bit longer. So, let me answer 1 or 2 more comments, and then I'm going to try and speed through one. Someone says they wonder what it takes to check and confirm it only has 1 solution. It would be checking each way you can arrange 10 different shapes on the grid, maybe telling your computer to skip certain formations that are definitely impossible, like anything that was just a rectangle smaller than a 1x3. And all the formations of 10, you'd then tell the computer, check which ways you could fill in stars, and don't count the ones where the stars are next to each other or break the basic rules of it. And then you would tell the computer, tell me the ones where there was exactly 1 way that the stars fit. I don't know how you'd program the computer to do that, though, but Crazy Dad apparently does, and I would love to interview this man someday. So, somebody also says they've set many puzzles, if you mean like sort of designed them. I'm not sure if that's what you mean, but I've tried designing puzzles myself, and I have. Someday I'll show you some of the old puzzles I designed a while ago. Not exactly this type, because I'm not a computer programmer, but other sorts of puzzles. Crazy Dad designs his own ones, too. He has a lot of homemade combos. There's a new version I want to try later in the stream, maybe, where he says it's a mix between the 8 Queens chessboard puzzle and Do Not Touch. So maybe we should try that one later. First, let's go to the next puzzle in this book, and I'm just going to speed through it for one, and you folks can see if you can figure out what process I'm doing to solve it or not. While I'm doing this, feel free to leave any comments about your own favorite puzzles or other puzzly thoughts. Also, feel free to comment if there's any moves that you don't understand how or why I deduced them. And maybe I can backtrack and explain them. I'm not super speeding through it this time, but I'm definitely not explaining everything I'm doing either. And there are many other puzzles on this site, so after I do this one, I think I'm going to run inside to grab some water anyway, and so if anyone needs a break or gets bored of me solving it on my own, come back in a few minutes in either case, because after I grab some water real quick, we are going to try some other puzzles that are on Crazy Dad's website that I think also have simple rules but complex ways you could analyze them. Yeah, I'm not going super fast on this one, but let me think about what we can deduce on all this. Also, I do sometimes make mistakes. I'm assuming I haven't done that here, but there are times where I end up not getting the right solution. You end up where you're like, what? I can't fit them anymore. What's happening? And it means you have some in the wrong spot. But that just means I rushed myself too much when that's the case. Okay, what other obvious things can we deduce here? Or non-obvious things? And I'm not paying attention to any comments right now. I'll check them in a minute. But do feel free, if you want to comment, if there's any strategies you would have done that I didn't do. I find these very relaxing. There have been times in my life where I had to get over some problem or another, or was in some sort of bad state or another, and where doing 2-knot touches greatly helped. Oops. The hard part is well, not the hard part, but one hard thing is you'll be scanning for like a really complicated technique, and then you have to remind yourself every once in a while to just check for basic stuff, like a zone that is now shrunk enough that here, like this, to a really obvious state. So you have to just sort of go back and forth between checking for obvious things and seeing which weirder calculations end up helping. There we go. So that one was 6 minutes, 18 seconds. This is actually a number that shows up a lot in my life. 6 and 18 together. Now, that's fun. Usually I try and time myself and really try and go as fast as I can, like hyper focus on it. And that will usually be on the upper end of any of the times it takes me for the like high level book ones. And on a good puzzle, I can often get it in 2 or 3 minutes on here. I think I could do it faster by hand too, though, on paper. And then on harder ones, sometimes it takes me closer to that range of 5 or 6 minutes or something. But there are different puzzles that different techniques do or don't help you with. So maybe I will develop even more techniques. Somebody says I've gotten the hang of pretty much all the necessary techniques, and I'm solving the puzzle in almost the same way they did. And while there's that amount of, quote, necessary techniques, you can go beyond necessary techniques to speed things up and to get quicker deductions. So I have enough techniques to solve any puzzle without needing guess and check, but I think I could still develop more techniques to speed up the process. So now let's, maybe we'll try one more of these, but for now we're going to go back to Crazy Dad's main site, and we are going to look at some variety of other cool puzzles. However, I need to run inside and grab some water real quick, and so let's shrink this, and you can leave a comment about if there's any of these you especially request. I know that we're going to try this one called Inkies, also known as Ken Ken, and we're probably going to try his new one where he says Star Battle, which is, for some reason, 2-knot touch is the name New York Times wanted him to use for it, but Star Battle is a more like original name to the puzzle, and I think he even prefers that name based on this description. Star Battle meets chess. So we're going to try that one. Leave a comment if, oh, and look at all these different ones. Okay, leave a comment if any of these are particularly intriguing to you. Other ones that I've had a lot of fun with before, if any of you try them on your own. Futoshiki is great. Bridges is great. Galaxies was a whole different strategy. I never went that deep into that one, but it looked cool. Oh, Slitherlink was cool. So, yeah, there's a lot of different options on here, and leave a comment if any are your favorite. For now, I'll just leave a really shrunk version of this page up so you could see more of them, and Also, leave a comment if you have any other puzzles you enjoy or any other puzzly thoughts. I'll be back very soon and we'll try a couple more of these games. Okay, I'm back, folks. I've returned shortly as much as I could. That'd be funny if someone said they'd return shortly and then they went to a shrinking machine and they returned really short. Okay, so let's try some of these puzzles. And puzzles, games, however you define them. This is, like I mentioned, where we start seeing the merger between whether you'd call something a puzzle or a game, so we'll go with puzzle games. Somebody noted Martin Gardner probably would have appreciated this site, and I'm sure he would have loved it. I bet Martin Gardner would have written articles about Do Not Touch if he had known about it, because he covered many other similar-ish puzzles that were popular back in the day, and I believe Martin Gardner has written about Sudoku. He's written about many similar puzzles to that. Now, somebody notes a technique called penalty theory. I don't know exactly what that described, but I will look into it sometime. Now, somebody says they like the way completed bridges puzzles looks, and maybe we should try a bridges, because those were pretty fun. And I haven't done these in a while, so we're going to start with one that's not that hard. We'll try medium, and it says ascending difficulties, so we'll do a random volume, but ascending difficulties we'll do like book 5 out of 50, because I haven't done these in a long time. Oh, I have to click to download this one? Okay, some of them, I guess, since there's not an online thing, what you have to do is download them, but then I'm not going to be able to click on it. Am I going to be able to just draw on it? Okay, here's what we're going to do. Can I draw on it? Let's see. I'm trying to see if I can draw on this. Yeah, okay, this is going to work. Okay, so. Uh-oh. I don't know how to use what I'm doing, though. Something weird's happening. Okay. So, I'm going to try and draw on the bridges. Medium's pretty big. Maybe I should have done small. I'm going to go back to small, because medium's actually really big. We're doing book 5 of small now, and here's how it looks. And I can try and draw on this. So I'm going to draw our connections. Now, how does bridges work again? The rule, I actually forget how bridges work. So here's the instructions. So you connect the islands, so these are islands, to form a network so that you can reach any island from any other island. The numbers on each island indicates the number of outgoing bridges. You may only connect islands horizontally or vertically, and you may use 1 or 2 bridges to connect islands, but not more than 2. So that means any 2 of these circles can have 0, 1, or 2 lines that end up connecting them. And like we can make a double bridge if we need. And oh, so yeah, we can't make bendy bridges, I don't think. I think bridges must be connected with a straight horizontal or vertical line, which we can have 0, 1, or 2 of from each of these to another. And each has a total amount of bridges coming out of it that's the number in it. And they all must be connected to the network. So, let's try the bridges puzzle. So, is this going to work? Yep, it's going to work. Okay. Now, 1. We know this only has 1 bridge. Well, what's going to be easiest? I forget. To target the low bridges or the high bridges? Let's see. 4. That might be the easiest because, yeah, it's in the corner. It can only connect these ways, so it needs a double bridge to each of those. So we have double bridge, double bridge. Now that's a 4, so it has 2 more bridges coming out. They could either both go there or be 1 up and 1 to the side. How about this 4? It doesn't have anything that way. Still, it's not quite enough information for us to know exactly where it goes. So, let's think. This is a 2. If it has 2 going there, that would fully connect to that. It can't have both going there because then 3 wouldn't have enough. So let's think from the 3 here. This can only connect to those 2s, so they each must have at least 1 coming from the 3 because if they had 0, we couldn't fit 3 bridges off of this. We can only have up to 2 bridges connecting any 2 particular islands. So it has, we don't know where the third one is yet, but it has at least those. So this has at most 1 coming out of there, from there to there, meaning it has at least 1 going from there to there, from that 2. Now, what can we do next? Well, where are some that are big numbers compared to how much stuff they're pointing at? That's what I'm looking for at the moment. Like with 4, let's see. Or let's see, how about this 2? If they both go up there, 1 would have to go, So, I forget the strategy of bridges. It's kind of fun to have to figure it out from scratch. And think of like, what strategies do I do? It's different than 2 not touch. Do I want to draw a different colored line for places I know it's not? Or what? For now, I'm just drawing bridges where I know they are. So, from this 4, it had 2 going there. It can have at most 1 going there, so it needs at least 1 going there. From that 4, I'm not sure. From this 4, I guess it could just have a double connection to some stuff and not have those guaranteed. What about the 1? If 1 goes to 2... Okay, we'll go to this 3. 3 is only touching 2 numbers, so they each need at least 1, because it needs 3. Similarly, this 3 is only touching 2 numbers, so it needs at least 1 to each. And where can we go from there? This 2 either goes that way or that way. I guess targeting the highest numbers, or numbers that are in positions that don't align with many others, are the goal, but maybe the low numbers are useful in their own way. So, what else can we show? There's 1, 3, 2, 1. What about this 2? It can have at most 1 there, so it needs at least 1 there. Now, we've used up some of 4, but 4 does get some more in there. This 1 could go there or there. 3. It's very fun to me. Sorry if it's not the most interesting part of the live stream, but it's very fun to try and think about how to approach a problem that you only know the rule set of. I did do a few bridges way back in the day, like 2 years ago, but I completely forget what strategies I used for that. Oh, no, what's happening? Okay. There we go. So, I don't need that box. Okay. What else can we deduce about these bridges? 2. Not sure about that one. 3. 4. Well... yeah, I'm not sure about this bridges one. Leave a comment. Somebody said it might help to slash off any island that has all its bridges. That could help, yeah. So we'll just like fill them in because we don't care about your number anymore. You're done. You're done. And are there any others that have all their bridges? I think that's all. So this whole corner is sort of done, but let's see. I want to figure out where we can go next from here somehow. So, this 2 in the corner, it gets 1 more. If it goes there, then that uses up this 2, so that 3 would have another going there. And that would use up this 2, and I'm not sure if that's necessarily a problem or not. Let's think about the other option. If the 2 has a double line there, then 4 only gets 2 left. So, oh, this was obvious. I don't know why I missed this one. That one did have all of its stuff, like crossing it off did help, because now I see that 3 needs to have another line there, and that fully uses up that 2. So, these are done now. So, that probably helps a lot. 1 now only can go that way. No, never mind. It could go down. How does that help? We've eliminated something that would have touched and something that would have touched. 2 can only have at most 1 there, so it needs at least 1 there. Islands, can bridges cross? Can bridges cross each other? Bridges may not cross. Okay, so we know that doesn't go there. So 3 has at least 1 going down. And that 2 can't have both going to that 2, because it only has 2 down here and it already has 1. So it has at most 1 going down and at least 1 going up. That eliminates that 1's direction, so 1 has to go down there. Now 3, so we can cross off 1. And what's next here? So this 3 either goes down or over. That 3 either goes down or over. What can we deduce next? I keep feeling like, oh, maybe I should give up. Maybe we won't even get this. But we're going to get it. I'm not going to give up. I prematurely cancel that thought. So, 2. Can that help? No. What about this one? What about this one? 3. It's used 1, so it gets 2 more. Could they both go down? Maybe. Could they both go over? No, they can't both go over, because then this 2 wouldn't be able to have enough without that having too many. So we need at least 1 to go down. Because that 2 can't have both of it go there, or that is too much. That helps a bit, but how does this help? Now, let's think of a sort of ripple effect. If that went over there, it would use up the 1 and block that. So that would have to go there. That would use up all of that. So that would have to go there. And the 1 would have to go there then. That would use up all that. And then there wouldn't be enough for the 3. The 3 wouldn't have enough stuff, because this would be way too full. Let me go through that thought process one more time to make sure before I cross anything off. If 2 went there, that would use up the 1. So that 2 can't go there because it would cross. So it has to go there. That uses up the 4. So since the 1 was used up, the 2 has to have another going up there. The 4 would only have at most 1 that could go over to the 3. And where else is the 3 going to go? The 1 was used up. In fact, at this point, we could have just said that 3 can have at most 1 go down, so it has to have 2 go over. That line really helped, knowing that that 4 got blocked off from the 3. We need a double bridge. And we need a single bridge. That's actually just like that 3 tells us all that. Which, you know, I got there by thinking about how this couldn't go that way, but this could have been a quicker thought process for it. Now we've used up our 3 and our 4 and our 1. Now, this needs one more going there, and we've used it up and used that up. That means this one has to go down. Wait, uh-oh. Something went wrong. Something went really wrong. Something went very wrong at some point, folks. This 2 has a problem. Maybe I should have just X'd these out instead of scribbled them completely out, and then I would see where the problem was. Oh, man. Okay, I messed up that bridges. I'm going to try one more, but we're not going to worry about persistence. If we can't get this next bridge pretty quick, then maybe we'll give up. Maybe we should have done book level 1 instead of level 5. But this one seems easy. And to answer a question in the chat, yes, a double bridge is the maximum that 2 particular islands can connect with. And somebody also reminded me that all bridges must connect. I forgot that rule. That's a basic rule. All bridges must connect. We cannot just have an isolated subgraph. So, and somebody noted a little earlier, I should have looked at the chat. Somebody noted earlier that this isn't going to work. So, okay, we're going to try one more, and this time I'll check the chat in case anyone's like, stop. All right, 6. 6 seems like it could give us a lot of information, but it's touching a lot of directions, so maybe it can't. What about 5? Well, okay, let's start with the corners. 3 needs at least 1 going each way because it's a 3 that's only touching 2 things. This 4 is only touching 2 things, so it needs a double bridge connecting them. And now we're not going to completely scribble out the 4 like last time. We will just circle it like that to mean it's done. Now, this 5 has used 3 of it. It must have at least 1 going up because it can't use that many going that way. Now, this 1 only has room to go up. This 3 needs at least 1 going up there now. And this 3 is only touching 2 things, so it needs at least 1 to each. And this 2 is only touching 1 thing. Is this one a lot easier than the last one, or was I just... I don't know if this one's easier. I was being dumb during the last one, or I got significantly better because the one like taught me something. I don't know. Or situation 4, it's a trick and only the beginning's easy. So what else is in corners? We know this. Or option 5, this is all a simulation. No, okay, never mind. And this one's only touching 2. Okay, so let's circle the ones that got completed. Ding. And ding. So, what else do we know here? This 3 used 2, so it needs 1 there. And that finishes it. Let's see what's next. This 3, this 2, 3. So, now maybe we need to get a little further with what techniques we're using. Maybe we hit the less obvious part. So let's think. If 2 goes up there, 3 has another one there. I don't know if that's necessarily a problem. If 2 goes over there, the 1 would have to connect to one of these, which, theoretically it could. What about the 4? The 4 can only have up to 1 there, so it needs 3 between those ones, which means it has at least 1 to each of these. Now, does that block anything? I feel like that's the technique if you wanted to do these fast, is whenever we make a bridge, let's see what got blocked. Like 1 can't go over there anymore. So now 3 is only touching 2 things and needs at least 1 to each. And did we block anything else? I'm not sure. Now, what about this 2 and stuff? Okay, so this 3 could only have up to 1 there, but it could be over there. But could this 2 have... This 2 can't have both of them going to the 3 for the rule I had forgotten before. That would be an isolated section of bridges that don't connect because the one is used up. And if the 2 has 2 connections going to the 3, that would work, except that this would be a chain of bridges we can't reach anywhere else. It would use them all up. So the 2 doesn't have a double connection going that way, which means it has at least one going this way. Now, what else can we deduce? What about this 6? The 6 can have at most 1 going there, because that one already had 3. And it could have 1 more there and 1 there if it didn't touch the 5, I guess. Theoretically, that could be possible. We also need to connect the 5 to stuff, but that's going to happen because it's a big enough number. What about 3? If 3 doesn't have a double connection to 2, 3 does have at least 1 connection to 5. And that blocks this. So now we know that's double. And that uses this 5. Now we know that has to be there using that 3. And that. And now this only could go there. And that's used up. So we have to make sure all of them connect to this guy somehow. Because we need all the bridges connected. So, 3, how's that going to connect? Let's see. What do we have now? I feel like that should give us a lot of new clues. The 1, I guess, is only touching that, so it has to go there. The 5 now should have 2 more. And let's see. Oh, the 5 can't have the 2 be... Wait, is this a problem? Because are we going to... Yeah, the 5 can't have 1 more on each of these 3s. Because if that used it up, it would be an isolated subgraph. They would all be used up. Wait, no, the 2 wouldn't be connected. So maybe that is possible. Okay, we'll ignore the 5 for now. What else do we got cooking here? Well... 3, 1, how about this 4? What about the 6? So, the 6 can't have a double going that way. So it needs at least 1 going that way. Now, because the 3 only has 1 more coming out of it, there's at most 1 coming in that way. 0 to 1 there. And then each of these are 1 to 2. 5's almost used up. 5 only gets 1 more. But that makes sense because it has a bridge on all the remaining connections anyway. Could 3 go up? If 3 goes up, that uses up the 2. This 3 has to go there, using up that. This 3 would go there. I don't know if that's a problem or not. Now, what about this 2? Now we got to look for ones that have reached that state where their number's big compared to how much they have left. How much room we know they could fit connections in. So, Now I am hitting a trickier point on this puzzle. Let's think of how we can deduce this. Let me check the comments. Someone says 2 to 4 is a double. I'm not sure if that was previous or if that's a current thing. If you know that's a double. Oh, you do. You're correct, if that's what you meant. Because we cannot go downward. Oop, so that's a double. And now that uses that 2 up. What does that tell us? Well, are there any ones that have become obvious now? Let's see, if that uses that up. We need to connect through one of these ways to make it all go together. 2 going up wouldn't help connect because it would use that up. So we need to connect either through 6 or 4. At least one of those has a connection. Now, any other clues? Anyone else notes things? Leave a comment if you have any thoughts. But I'm going to keep at this because I think we're pretty close. So, are there any that are now blocked off from things they hadn't been blocked off from before? Oh, well, that 2, I guess, is used up. If we always cancel out the used up ones, it may help, even if just visually. So here, this is like, these are the first non-used up ones on this corner of it. This has 1 more coming out either to the 5 or the 2. And same with this, with its own 2. Let's think. If 1 went down to 2, that uses up 2. 3 has to go up to 5. That uses up 5. That means 6 couldn't fit because it couldn't cross it. 1 can't go down to 2, I think. Because if 1 went down there, 6 is blocked from going there and would need a double on each of these, which would use up 5 in that way. But here, if 1 went to 2, that uses up the 2, and 3 would also need to go to 5, making it too much. So 1 can't go down to 2. I don't know how to draw that on my notation. I'll put dots, I guess, to mean don't make a line down this way. Don't make that line. I don't know if that'll probably get really confusing later, but whatever. So we know 1 goes one of these ways, at least. And if 1 doesn't connect to 2 that way, 2 goes there. That's just what I should have drawn. Okay. Now, we've gotten those covered. And so 5 has to go a different way. And 5 has to either go toward 3 or 6 for its remaining 1. So let's see. Where does this one go? 3 gets 1 more. Oh, this 1 only is lining up with 1 now. Because, oh no, it's not. It could go over to the 4 still. So wait a minute. If this 1 goes down, that 1 has to go up. And we could connect that way, I think. Maybe. I need to look for more eliminated things. I can't, no guesswork here. Somebody said it looks simple and complicated at the same time. And it does. And somebody said, can we talk about other interesting math problems too? Well, today's theme is math puzzle problems. And if you want other ones, then earlier in the stream, we've done several. And later in the stream, we'll do others as well. But I want to try and solve the bridges, see one of these till the end. Now, if you mean non-puzzle game like math things, that may be another day. But as a reminder, make sure you've all seen the episode I linked in the description here. That is the latest long one on the Combo Class channel. And I do have bonus videos about math problems that I'm working on this annoying technology thing with, of trying to get them to export in the correct color brightness settings. So, this 1 could go either way. The 6, I feel like we can show the 6 goes to the 3, but how can we show that? If the 6 didn't go to the 3, it would double go to each of those, and the 3 would go up. That would go there, and that would go there, and that would go there. And that might actually work as a solution, so I think maybe the 6 doesn't go there. Let's see. Okay, if the 6 does go there, the 1... Okay, if the 6 goes there, then it can only connect to one of the 4 or the 5. That would use up the 3. So this one would have to go to the 4, and the 6 would be going to the 5 again, and to the 3. This 3 would go up there, and this 1 would go there, and that might work too. But I know there's not 2 solutions, so I won't think too vaguely about it. We need to look for some concrete things. And somebody said that the 1 next to the 6 connects horizontally to the 3. Let's see if we can prove that's the case. If it didn't, it goes upward to that, because we said it can't go down. Well, we already showed that with that. So let's see if we can disprove it being able to go up. If it went up, that would use that up. This would have to go down there using that up. And the 2, and this would go there using that up. So this, or yeah, and then the 6 would have to go to the 4 and the 5. I don't know. Someone says the 1 has to go to the 3 because it would cut off the other 1, right? If the 1, if you mean, well, which 1 to which 3? Well, either one has a backup plan. If that one gets cut off, this could go up there theoretically. And if that one gets cut off, this could go to the 4 still theoretically. So somebody said if the 1 goes to the 4, it crosses the other bridge. So let me see what you mean by that. If the 1 goes to the 4, then crosses which other bridge that we'd need? Because if the 1 goes to the 4, we could... Okay, wait. If that goes there, that has to go there. I'm not sure which bridge it crosses. Because we don't need a bridge up there unless we do in conjunction. Let's think. The vertical one, the 1 to the 4. The 1 to the 4. Well, we don't know this goes up, because what if that one goes there and that one goes there? That would use that up. That would have to have one going there, which would use that up, and that would go around, but I don't know if that would necessarily cause problems. So yeah, if people have any thoughts, see if there's a way to phrase why we know that, because although I trust that some of your thoughts may be correct, until I come to the deduction of why it's the case, I don't want to fill anything in. So let's see. Oh, 3 has 2 used up, so it has at most 1 going there. And so 6 has at least 1 coming another direction. It's hard for me to think ahead as many steps as, like, one thing leads to a spiral one way and another leads to a spiral another way, and one of them will hit a contradiction eventually down the line. But I need to find a deduction that hits a contradiction sooner so we can actually, like, cross it off. So let's see. How can we prove certain things are going certain places? If this 3 goes down, then that uses up the 3, so that also goes down, using up that, and that also goes down, using up that. The 2 would need 1 more, and that would go down and use up that. The 5 would need 1 more, which would have to go to the 6. And the 6 would go to the 4. I think that actually works. Okay. I'm going to try something. I'm going to put this in red, or in a different color, yeah. No, okay, the old one's red. The new one is, make one of them different color. Okay, the old one we know is red, but I'm going to try something real quick. I think this works. That going there uses that up. That going there uses that up. That going there uses up both of them. That would then have to have a double each way. That goes up there. That works, right? I think that's the right amount coming out of each one. I mean, if you count the reds, not the weird dotted bit and the black ones. Is there any error there? I think that's correct. And we do have... Oh no, that doesn't work. This is a disconnected graph. This set of islands doesn't connect to the others. So now we're going to Command Z, undo all of those ones, turn it back to its original color, and now we know that didn't work. So now we know, because we need all the islands connected. 3 doesn't go down to 1, and 1 didn't go there, so 1 does go horizontal, like someone said a while ago. Now I agree that that must be deduced. So, draw. Draw, come on. Yes, draw. Okay. So, 1 goes there. No, what's happening? I just want to draw. Okay. 1 goes there. That uses these up. That means that this 3 has to go there. Using it up. Using that up. This 1 must go there. Using them both up. This 2 must have a downward bridge. Using it up and that up. This 6 goes over to that 3. Using up the 3. The 5 goes to the 6, completing the amount they each need. And in this circumstance, they are all one interconnected bridge. So, this, I believe, is our solution. Okay, let's see. I think he keeps the solutions in the back of these. So, I always have to not print the solutions page and just print the rest of it. So, let's see. Remember what this map looks like, kinda. And let's see if it looks like his answer to it. All right, it was number 2. It looked like that, right? Yep, that's what it looked like, I think. I think that's correct. Cool. We got a bridges, and that was with some help from some of your thinking. So thanks to everybody leaving comments. I'm going to start trying in my streams to shout out the names of people commenting more, because although the stream chat does show up next to it after it processes, I realized there's this weird, like, paradoxical effect where you can't add to a stream chat, and if anyone ever, like, deleted their account, or for some reason the comment, you could subtract from a stream the comments on the side of a stream. Like, if you deleted your account, you wouldn't show up in there anymore. But you can't add to it. So it seems like it will eventually shrink towards 0. Not that everyone's going to delete their account who commented, but it can only shrink downward, the amount of the stream chat eventually. The comments on the video can keep going. But in any case, I'll try and shout out people's names a little more often who are giving inspirations for things, such as somebody who predicted or had their own way of calculating that the 1 has to go over to the 3. Some people who were helping here were Body Press, Corvic Knight, Straw Hatton, King of Time, and Gunny Cam, and some others, and Wade Eberly. So now let's try another type of puzzle. So Bridges was awesome. And in fact, he notes here that if you like, sometimes he has like recommendations for other ones that are similar. Maybe that's not on here. But there's other ones that are kind of similar in their own weird ways. Here's a quite mathematical one that I like called Futoshiki, or More or Less. So in this one, it is Sudoku-esque in that you have per horizontal and vertical line, 1 of each number up to some range. No duplicates in those. But instead of having sub-boxes that also have that rule, instead you are given certain greater than or less than signs. So it says the smaller ones are easier. As you get bigger, it gets harder. Let's do 5 by 5, the second smallest. And let's just go a few books in. We'll do book 3. Well, it's out of 100. Okay, we'll do book 5 again out of 100. And here we'll try and draw in our answers. Now, sometimes to solve these in the past, I remember I would have to write little numbers in them of all the possibilities. If I was like, okay, this one has to now be a 1, 2, or 4 or something. We'll see if we need to do that. In any case, let's see what we know from this first puzzle. These have to be greater than, whenever there's a sign, that number compared to that number. And they range from 1 to 5 in any horizontal or vertical line. So like the 5's there already. So we have 1, 2, 3, and 4 in here. That one can't be 1 because it says it's greater than something. And that one can't be 4, similarly. It also can't be 4 because that's in the line. So this is like a 1 through 3, and that's like a 2 through 4 or something. Now this is also greater than something. So that can't, ooh, look at this. That can't be a 1 because it's not greater than 1. That can't be a 1. And that can't be a 1 because it's in the line with a 1. This is the one that has to be our 1. So my logic there was, you can't be a 1 if you're greater than something, and you can't be a 1 here because you're in the line with one of them. So this is greater than 1. That doesn't give us any information anymore. So we can almost like erase this sign because it doesn't matter anymore. Of course it's greater than 1. So now we have a 2, 3, and 4 somewhere here. And ooh, thank you much to Bardley Richardson, who left a donation saying, keep talking and take my money. Thank you so much. I love those donations, and they're going to greatly help as we set up for grade -3, so I can restock all my dice and a couple more used clocks and a lot of other classic teaching supplies we may need. So thank you so much, Bardley Richard. And let's continue our Futoshiki. So 4 is greater than that, so that's not a 4 or 5, and it's also not a 1. So here I am going to sort of put the little ones in there. I'm going to note that this one's either a 2 or a 3 because it can't be a 4 or a 5 or a 1. So what about these other ones in this line? Let's look at this line that has the 4 in it. So this right here can't be a 1. The 1 has to either be that or that in this particular line. Now, this one right here, let's see. Okay, how about this? This has a few already in it. So let's do the ones that have 2 numbers in them. So we have a 2, 3, and a 5 left here. What does this double chain tell us? That can't be a 1. Oh no, that can't be a 1. But neither can that. So that can't even be a 2. Because a 2 wouldn't be greater than any of them. So that can't be a 1 or 2. It also can't be a 5 because it's in the line of that. So I guess whenever there's just 2 possibilities, I'm going to write those small in the corner to help us. Now, that's a 3 or a 4. So greater than, that would have to be smaller than 4, which is the maximum there. And it can't be 1 because it's in the line of one of those. So this has to be a 2 or 3. Now, 2 or 3 is greater than this, so that has to be smaller than 3 at the most. But it's not 1, so it's 2. Now, since that's greater than, it's not a 2. It's a 3. Trust me, that's a 3. And, I mean, the way I wrote it. Trust me, that symbol's a 3. And also trust me that 3 should go there. So that was a 2 or a 3, so that's now a 2. And that one is a 4. Okay, what can we do now? This row needs a 4 and a 5, and we know 5's not there. 4 and 5. This row needs a 3 and a 5, and 5's not there. This one needs a 2 and a 3. Not sure about that yet. How about over here? We need a 1, 2, and 3. Are there any that the numbers are double taken up of those? Nah, because 2 could be either of those, 3 could be either of those, and 1 could be either of those. So let's look at this line some more. It has a place where it can't be 1. So either that or that was 1. What about 3? 3 could be in most of these spots. Okay, let's see. If that's not a 5, it's also not a 4, so it would have to be a 3, 1, and that leaves 5 there, which doesn't work. So this would have to be a 5. Let me double check that logic. If it was not a 5, its maximum is 3, causing that's maximum to be 2, causing that to be 1, causing this to need to be a 5 for that row, but that's impossible. So this must be a 5. And then we have, I'm writing these numbers sloppily, sorry. I'm not used to this type of writing. I'm used to typing. But now we have a 1 and a 3 that go in those spots. So I guess we'll write the small ones because they could help. 1 or 3. 1 or 3. And this does not mean that the number 13 goes there. Now, this is not a 5 or a 4, but it's greater than something, so it's also not a 1. Oh, and it's in the line of a 1. So this must be a 2 or a 3, and that must be a 2 or a 3. I'm going to write them in because if we get stuck, then using these, we can sort of use like a Sudoku-like strategy just with these to crack certain things. Eventually, we like use up all the info these give us, and it almost becomes a Sudoku-like thing. Like, already, and 5, of course, is bigger than that. So the only, like, sign that still affects anything is that. And that does affect something, because it's a 2 or a 3 here, so that has to be a 1 or a 2 here. Now, what about these? We need a 1, 2, and 4. That used up the 4, so we also need that to be 1 or 2. And since this was 1 or 2, that's the 4. So, now let's see. Here we need 1, 2, and 3. That's not a 1, it's a 2, 3. This is a case where we cannot compare just these 3 Sudoku style to get it, because 1, 3, 1, 2, 2, 3 covers enough gaps that there's multiple possibilities. But if we had like 1, 2, 1, 2, 1, 3, that one would have to be the 3. Or stuff like 1, 2, 1, 2 would mean one of those was the 1 and one of those was the 2. Now, here we have a 1 and a 5. That can't be the 5. So now here we have a 1, 2, 3. That can't be the 1. That's 2, 3. So here's an example. Oh my God, that's like practically what I said. I said 1, 2, 1, 2, and 1, 3, but it's like that. These must be the 2, 3, so that has to be the 1. And that has to be a 3. That has to be a 2. That has to be a 1. And I think we're at the breaking point where it all just sinks into place. Okay. Cool. So that made it all work and come together. And scanning it, it is correct. So this one's fun. He has tons of sizes of this. So you could do the way bigger sizes if you want a big challenge, and I've tried them. The 9x9s are pretty hard. I've gotten the easy levels, but I've also seen levels of these that, like 2 Not Touch is the one, or Star Battle is the one I took the most time studying, so I can get any of them with enough time. Some of these I haven't studied much, and so I've encountered puzzles I hit a dead end on. Now, somebody said Nerdle is another fun game. It's like Wordle, but you guess valid equations. Okay, I just have to make a note. Wordle, my mom plays Wordle in the morning, and she couldn't get the word, and she had me try and help her. And I was like, okay, here is like a sort of slang-like word that I really doubt it is, but try it. And it was it, and it's sort of ridiculous. It's not a legitimate enough word to have been the Wordle today. I won't spoil it. I already gave like a half spoiler by saying it's slang, but you kind of need that to like even normally you don't expect Wordle is going to put some random slang shortening of another word in there. So um, today's Wordle was a dumb word for them to choose. I was saying eventually they're going to run out of normal 5-letter words, and they're either going to have to move to just 6-letter things, duplicate words they've used before, or just start having really obscure words only. So, like, I looked up how many 5-letter words there are and calculated how long it was, and I think it was like, oh, they get like 30 years of one a day for all the 5-letter words. But like many of those are like some weird taxonomical name for this, or like are some very specific term in some field of science or something, and people don't know them. They're not a common word. So you're not going to make it 30 years unless by that 29th year, all the words are going to be so obscure. But yeah, I've tried the Nerdle one too. That's pretty cool. That was fun. Maybe we'll do that one later. So I'll put that in a tab in case we want to do that later. And first, there's another one that I remember being fun out of the Crazy Dad ones. And one of the others I remember being fun was called Binox. And excitingly, there is now 3-way Binox. Troix. I don't know how he wants us to pronounce that. But also known as Trinox. I'll call it Trinox. And yeah, so these two we're definitely going to do. This one is sometimes known as Ken. He calls it Inkies. Those are really cool. And they're, we'll do that one next. So somebody leave a comment with some random numbers. The first number is the size we should do. The next one's not a number. It's one of the levels that exists under that size. And then somebody else comment like which of the puzzles. Or comment a few random numbers. And we will pick a randomish puzzle. I need to run inside really quick again. I'm sorry, but I'll be back shorter this time. I want to do a nice long stream because I love these puzzles. So we'll probably run past the 3-hour mark. So I need another 2 minutes, and then I'll be back for a few more puzzles. In the meantime, while I run in, I will be eating this mango I dried, which, like I said, oh man, dehydrators are so cool. It tastes just like dried mango out of a bag for like 4 times cheaper. I've returned for the rest of our puzzles. And like I noted, we are going to start with this one called Inkies. That's what Crazy Dad calls them. I've seen them called Ken more often. And let me see, do they have other common names? Also known as Kendoku. So, this is a Sudoku-esque thing in that many of these puzzles involve numbers and the rule that any horizontal and vertical line contains one of each number from 1 up to how many slots there are in some order. That's part of why I liked To Not Touch so much, that it's a different type of rule. And the other one, Binox, I want to show is a bit different as well. But here we're going to try these Inkies, or Kens. And someone said 5th column... Oh, no, you're talking about the old puzzle. So, nobody commented a particular size. So, I'm going to pick a random size. We are going to do a 6x6. And we're going to do medium. Pick a random volume, medium. And we'll pick a random book near the middle. Hopefully I'm not biting more than I can chew. Let's see if we can get this here. The rules are, now we get 6. 1 through 6 fits in each row and column. And, oh no wait, yeah, that's true. But also, in each little cell, we have a rule for what they add, multiply, or divide, or such to. 3 divided by, for example, means that, what's the difference between divided by and times? Oh yeah, so here they multiply to 24. Here, 1 is 3 times the other. 3 divided by. We can divide 1 by 3. So, and here we have like the difference, and here we have the sum. And difference, I suppose, and divided by, I suppose, have to be 2 cells, because just mathematically, those are not things that if we had 3, we'd have a clear rule to follow. So the bigger cells, I suppose, have to be plus or times. So let's think about what's going on here. Well, here we have like a 30 times, and since we have only 2 cells there, we need the 5 and the 6 to be in there somewhere. So, kind of like the last one, let's use some help by drawing tiny stuff here. And we're going to note that each of these is a 5 or a 6, because we need those 2 to be able to multiply to 30 and 2. And that means these other 4 are not 5s or 6s. If we have them like all the numbers used up, it kind of destroys the rest of the line for those numbers. So, these are 1 apart. So, there's a few options for that. And there's no other clear ones in there. So, we'll move to some other stuff. A 3 divided by could be a 1-3 or a 2-6. Let's see ones that could be less things. 180 times. This could have duplicate numbers, though, because this one and this one could be the same number. They're not in the same row or column. And so they note that here even. Numbers in cages may repeat as long as they're not in the same row or column. So what could multiply to 180? We would actually need 566 to be that large. That's the only way we could make it work here is 6, 6, 5. Anything smaller than that would not work multiplying to 180. So that kind of gives us some freebies. Now here we know we have 2 that add to 7 that don't include 6. So that's either a 2 and a 5 or a 3 and a 4. These have a difference of 3, so that's either a 1 and a 4 or, again, a 2 and a 5 could be there. Now let's see. If one of these isn't a 2 and a 5, then it contains a 4, and the other must be a 2 and a 5. So there must be a 2 and a 5 somewhere in here. So that one's not a 2 or a 5. Now, what else can we deduce? 16 plus is pretty large. We don't necessarily need a 665, but for example, we can't even have a 1 in any of these. The others couldn't add up to 16. Can't have a 2. What's the minimum number? Could we have a 4 in some of these? If we have a 4, the only way to have a 4 would be a 4 there and a 6 in each of those. Otherwise, they're 5s or 6s. That tells me that this is either 5 or 6, this is either 5 or 6, and this one is 4, 5, or 6. Now, 3 divided by here could be 1, 4, or 2, 6 still. 2 divided by here can't use the 6, so it can't be 3, 6. It's either 1, 2, or 2, 4. That means one of these is the 2 in either case. So these can't be 2s, or 5s or 6s. These are either 1s, 3s, or 4s. And let's see. Do any of those not work? Any of those maybe could work. Well, actually, that can't be a 3 because if it adds to 6, we'd have 2 3s in the box, and they're in the same column. So that can't be 3, and it couldn't be 2 because one of those had to be. So that's either a 1 or a 4. Now, since they add to 6, that's the complements of these, so that's either a 2 or a 5 to make them add up. Now, here, I'm not going to fill them in because they're... Well, I guess I'll note that each of these is either 1, 2, or 4. That actually helps a lot because, look, this is either a 1, 2 and a 1 or a 2, 4 because it can't be a 3, 6. So there are 1s, 2s, or 4s in there. And that was a 1, 4 there. Why was that again? Why was that? Oh, yeah, it can't be a 3 because it would need another 3 to add to 6. So that has to be a 3. Now, that's either a 2 or a 4 because of that. And let's see what else we can deduce. So let's see which row or column will be the most helpful to approach next. 12 times is either 2, 6 or 3, 4. Could be either of those. This one can't be a 6. Or, well, let's look at this line. So 5 and 6 are sort of eaten up there, and 3 is there. So we have 1, 2, or 4 in the remaining ones. That can't be a 1, so that's a 2 or a 4 to make the times 12 work. And that leaves that being either a 3 or a 6. Now, let's see where this leaves us. If that's a 2 or a 4, and that's a 2 or a 4, that's only could be a 1. That's all that's left. And now 3 divided by means we need a 3, because then they have 3 as what one can divide by to get the other. So that's a 3 and that's a 1. That leaves 2, 4, 5, 6 in these spots. Let's see what else we can deduce. 3 divided by here is not 2, 6 because of that 6. So it must be 1, 3. So these are each 1 or 3. This was 2 or 4 and that's 2 or 5. So which of these, this can't be 1 or 3. Those are used up in that line. So this theoretically could be a 2, 4, or 5. Would those all work? 2 would make 5, 4. Theoretically, maybe they could. So let's look at some other things that give us a lot of patterns. Let's see if we can get anything over on this edge of the board. 2 divided by either is 1, 2, 2, 4, or 3, 6. Are any of those impossible due to what they would eliminate? 2, 4 would leave that as a 1, that as a 3, and those would be 5s or 6s. Now, 3, 6 would make sure that's a 1, that's a 5, that's a 4, that's a 2, so that's possible maybe. 1, 2 would make that a 3, 4, 5, and 6. So maybe that we can't get any clues from quite yet. Where else should we look? Now, how about 2 minus? That can't be a 1 to 3 because that would use up both of that one's possibilities. So that must either be a 2 to 4, 3 to 5, or 4 to 6. And that's too much for me to want to write in now. We need more condensed clues than that. How about 9 plus? Well, we can't have it include any of both of these for any of these because it would use up the possibility. So it can't have a 2 and a 4, can't have a 3 and a 6, etc. Now, if it had a 6, that would leave it needing a 1 and a 2 to make it 9. And theoretically, that could be possible. The 6 would have to be there. And if it had a 1, that would leave the others needing to be a little larger, unless it was 1, 2, 6. So, what can we get from that one? Maybe we need to look over here instead. Let's write on the side some notes we knew about these fellas. This one was either a 2, 5 for those, or a 3, 4. For what these ones are. And for what these ones are, it can't include the 6, so it has to either be a 1, 4 or a 2, 5. We showed that one of these must have a 2, 5 in them, otherwise it would be a 1, 4 and a 3, 4 with 4s as a duplicate. So 2, 5, and 6 are used up, and this one could only be a 1, 3, or 4 itself. So let's just note that in here that this could only be a 1, 3, or 4. This one right here can't be a 5 or 6 either. Although it looks like a lot, I'm going to note that it could be a 1, 2, 3, or 4. So let's see. The maximum these could add up to, they can't both be 4s, would be 7. So that can't be a 1. That must be at least 2 here. And it also can't be a 3. So that one has to be a 2, 4, 5, or 6. I don't know if all this writing will help or just get in the way, but often we can deduce Sudoku-like things using this. So what we're looking for is things like if there were 4 numbers that between them only contained 4 different possibilities, they would have to include all those and eliminate them from the others. But I'm not sure if I see that case here yet. Let's analyze some other spots. 24 times. Okay, this spot right here can't be a 1, 3, 5, or 6 because it's in a row with a lot of things. So that spot right there has to be a 2 or a 4. That leaves these two multiplying to either 12 or 6. If they're multiplied to 6, it would be a 1 there and a 6 there, or a 2 there and a 3 there, I guess. If they multiplied to 12, we'd have a 3, 4, or 2, 6. So let's just remember these multiply to either 6 or 12 now. If that's a 2, 4, that's a 4, 5, 6, and that's a 5, 6. Let's note what that is. That one in particular, we said was either part of a 1, 4 or a 2, 5. But it can't be the 1. It's either a 2, 4, or 5 as its possibilities. So, where can we go from here? Am I just going to need to end up filling all these in? No, we'll find an interesting pattern soon. Although, like I said, maybe I bit off more than I could chew by not having done these in a while and then jumping into the one he called medium level. So, we'll get it, though. Slow and steady wins the race by not making mistakes. Now, let's see what else we have notable patterns about. This 3-, we said, has a few options. This right here, let's look at this row, because we have 6 and 5 eliminated there. We have 1 through 4 out of these ones. So that one could be 1 through 4. If it was 4, that could be a 1, but otherwise that has to be the one that's 3 larger. So let's see. Where else do we have things converging with a few things in a line that could maybe give us info? This line, let's fill in what that has to be. That would have to be a 2, 4, or let's see, we had 2, 3, 4, or 5, but 3 is eliminated from those. So this is a 2, 4, or 5. Kind of like that one was. Maybe that can help us in a minute. This one right here is the complement of one of those in terms of 7. So it's a 2, 3, or 5. And this is getting messy. And the one above it, here, I'll erase the 5 and put it closer so I have a little more room later. The one above it is that also? That could be a 2, 3, 4, or 5. So, yeah, that one, we'll write them, but it has a lot of possibilities. Now, sometimes a cool pattern you can find is like, you see how there's 1, 3, and 1, 3 together? If we add another 1, 3, 1, 3 somewhere, it would eliminate all the 1s and 3s from both of those, because we know it's either like ding, ding, or ding, ding. But we don't have stuff like that right now. But there's a lot of patterns this has in common with how you could think about Sudokus. But I prefer this twist, as opposed to you get your standard boxes. This one has little equations. So, where can we go from here? There's got to be some more info we can deduce from here. First, let me make sure I'm not missing anything that should be crossed out. Okay. Now, I'm just going to fill in a few more, I suppose, and see what patterns pop out from that. This one we noted can be anywhere from 1 through 4. 1, 2, 3, or 4. This one can be 3 apart from one of those. And so it can be 1 by being 3 under 4, or it could be 3 over one of these. 1, 4, 5, or 6. Yeah. Okay, this is sloppy. Okay, 1, 4, 5, or 6. We know that's a 4. Now, what else do we have going on in this line then? 1, 2, 4, 5, 6. Could this be any of those? This can't be a 1, because if this was a 1, remember this multiplies to either 6 or 12. This would have to be a 6, but 6 is used up there. So that's not a 1 or a 3. And so that one has to be a 2, 4, 5, 6. We're just writing them in. So let's see if we can deduce anything from this. 2, 4, 5, 6. Like one of these is a 1, but we don't know which. And between these we have our 6 somewhere. Let's see what else is here. So if these multiply to 6 or 12, is everything from 1 through 4 a possibility or not? If this is 1, that could be a 6. So yes. If this could be 2, with that being a 6 to multiply to 12. No, it can't. Well, if this was a 2, it would have to be paired. No, 2 can't work, because here's why. If it multiplies to 6, it would be 2, 3, but we have a 3 there. If it multiplies to 12, it would be 2, 6. But 2 can't have another 2 there, and 2 there was the case where it multiplied to 12 and not 6. So there's not a 2 there as a possibility. We're going to turn this into another number. No, we'll just Command Z it. So there's not a 2. There could be a 3, I think, because, yeah, we could have 3 paired with stuff. Or I think we could have a 4. So that's 1, 3, 4 there. A lot of small numbers, and we might as well finish it off. And then our goal is to shrink or eradicate some of the small numbers. So over here, what are our possibilities? Let's just go through them. Oh no, these don't have any definite ones in them. So they're going to... well, we know things like it's not 1, 3 there, actually, because it needs to be one of 1 or 3 there. So it's not 1, 3 here. There's either 2, 4, 3, 5, or 4, 6. And I think any of those could theoretically work. So we need to think further about other strategies to make this work. Let's look at some lines and think about some possibilities. So 5, 6, 1, 3. I feel like this 5, 6 mixed with these 5, 6s could theoretically give us some good help. Because in here, if we had a 5 in any spot, that would have to be a 6. And that would have to be a 6. Or if we had a 6 in one of the spots, they would both be 5s. Not sure if that helps. Okay, so maybe I should have done a simpler, more basic one of these as an example, but that's okay. We'll come back and do more of the Ken Inkies another day. Let's try another type of puzzle just to keep it rolling through a variety of different puzzles. And I am going to try to add timestamps to this stream and do that in general on long streams to show which puzzle was when, because this is like the 5th or 10th puzzle we've gone through. There are plenty of ones to check out previously in this stream, which the streams are available as videos after. Now, let's go to a different type of puzzle, though. No, I do not need to save it. So we're going to go to one called Binox, and then maybe we will try Trinox. So, Binox, or X's and O's. Where is that? Where'd you go, Binox? Oh, I swear, it's here somewhere. Where'd Binox go? Maybe they have a link to it from here. Yeah, I don't know if it was on the front page. Okay, let's do an 8x8, but instead of challenging, we'll do novice. We'll do the second easiest setting. Here's the rules. Well, actually, this will be interesting to read. It says the rules are pretty simple. The puzzle is filled with X's and O's. Horizontally and vertically, there can be no more than 2 of the same symbol touching. So, in a row or column, you can't have 3 in a row of the same symbol. It's almost like anti-tic-tac-toe. There are an equal number of X's and O's in each row and column. So, that's why there's only even-sized puzzles, because this means 5 per, 5 X's, 5 O's, 4 X's, 4 O's, etc. And each row must be unique, each column must be unique. What that means is that you cannot have, like, if this goes XXOOXO, I can't have another repeat that exact pattern. He notes, though, the main differences in the difficulties are that only on the harder puzzles do you need to incorporate Rule 4 to solve it. Still, we're not going to do the hardest. We'll come back to harder ones another day once I have studied these more. At the moment, the only one I've come back to actually test my skills on is Two Not Touch or Star Battle. These ones I'm doing these for the first time in like 2 years, so forgive the sloppiness. Now, let's try a random book. So, we are going to try to draw on it as we've been doing, and we'll see if we need rule 4 or not. So, we can't have 3 in a row. So, these must be X's. Whenever we have a 2 in a row, that's a big clue. That row got solved just by that. See, this is solving a lot of it just by looking at the 2 in a rows and knowing they can't be 3 in a rows. Now we can incorporate the other rule where it said equal amount of X's and O's. This needs an O to balance that column. So how about here? We've used 2 X's and 3 O's. That has to be an X because of up there. Now we get 1 more X. It can't be there or we'd have a 3 in a row. So we need our other X to be there. And then we get these ripple effects whenever we solve one. Okay, how about here? We get 1 more O and 2 more X's. All right. Where else is there some stuff we can calculate? Well, this column's basically done. To match the right amount, we need an O. Now let's look for imbalanced columns, maybe. Or columns, like here, we have a gap. That's another rule, I guess you could note. If you have 2 of the same type with a hole in the middle, it can't be the same type, so it must be the opposite type. Like O must have an X between. Now, this one gets 1 more X and 2 more O's. So let's look for more of those, like the gaps where we have a sandwich. We'll call that a sandwich. When you have 2 types separated, you must have the opposite in between. Now, where else can we calculate some things about our Binox? Well, here we got a 2 in a row, so that's a freebie. There we get a sandwich, and there we get an equalizer. That's what we'll call the rules. A double, a sandwich, or an equalizer. Equalizer meaning same amount of O's or X's. I don't know if we need a nickname for rule 4 or not on this version of the puzzle, where they must be unique patterns. All right, this one gets 1 more X. It could maybe go either place, and 1 more O. And, oh, thanks a lot to Wade Eberly or Eberly for another donation, who said there's a Nerdle variant called Cross Nerdle that is similar to the Inkies or Kenkens. That sounds cool as well. So I'll add that to a tab, and whether or not we get to these during the stream today, I'll either get to them in the stream or try them myself later, and maybe put them in a future stream. So again, thanks for the donations. Always helpful. Here we get a sandwich, and we get the and we get the opposite type in the middle. Where's my pen? And then we get the opposite type within the middle of a sandwich. What else? What other patterns? Well, there's a sandwich. And now we used all the O's in that row, or in that column. So we need X's. More sandwiches. Okay. This only gets 1 more X. It can't be in the sandwiches everywhere. Let's see. Here, we get 1 more of each. Oh, that's a 2 in a row. That's a double. Okay. Now here, yeah, these, we're not going to need rule 4 on this level. Another day, maybe we'll try, this is the equalizer, we need O's. Maybe we'll try one where we need to incorporate that rule. It's hard enough that we need to look at, okay, this pattern, OX, 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 XO, cannot repeat in another one, which is a whole nother level to it. You could look at these as 0s and 1s and do some interesting binary analysis, perhaps. It is called Binox. Now, this gets 1 of each, and are there... Oh, that's an equalizer. And now those are equalizers, and now that's an equalizer, and so are these. All right, let's see if that looks right. I don't know if I'll be able to compare and memorize, but we'll see if it looks approximately right to the answer. There's the answer. I think it looks right. Okay, that's Binox. I've never tried Trinox. That's apparently the new one that he came out with. So where's Trinox? Or he spells it like that. I don't know if it's Troix, or like Troy, or Troy, like a more French pronunciation of some sort. Okay, this is his name for a 3-symbol variation of Binox, also known as all these other names. These puzzles are a bit harder than Binox puzzles, especially if you are new to them. Uh-oh, we're new to them. I would start with the 9x9 regulars and then check out the diagonal and Sudoku variations in larger sizes after you've mastered those. Oh, so there's different types. The variations are... Wait, this is weird. Why does it say there's 2 variants and he lists 3 things? Okay, we'll skip those. We're not doing the variations anyway. So the rules are pretty simple. The puzzle's filled with X's, O's, and I's. Horizontally and vertically, there can be no more than 2 of the same touching. Same rule as before. Equal number of each. Same rule as before. No Rule 4 exists. It says, unlike Binox. I like how it is a rule. Rule 4 is that, unlike Binox, Binox's version of Rule 4 does not exist. No row column uniqueness rule. So let's try oh, he has an interactive version of this one. That'll be simpler than trying to draw them by hand. So let's shrink this so you can see the whole puzzle. Can you see the whole thing? Here, I'll slide it up a little. There. Here, this is just... I just want a white screen in the background. No, I just want something nice in the background. Okay, here, I'll just put you guys on the background. The edge of your comments get to be in this one. So, here, let's try Binox, but with 3s. Now, of course, each size of this must be a multiple of 3 because we need the same amount of each symbol. So books get harder, presumably. Let's do the first one. No, okay, we'll do the second puzzle in case the first one was like so easy to just teach a beginner. Well, okay, we'll do the third puzzle because it's Trinox. Okay. Here's the third puzzle. Let's see, we get O's, X's, and I's. Now it's a lot harder because when we have a 2 in a row, I know it's one of the others. I don't know which of the others. But here, I got a good one. 2 O's in a row means that can't be an O. And sandwich of X's means it can't be an X. Gotta be an I. Okay. Now, there's a sandwich, but it could be an O or an X. Also, we already used up 3 of them in that line. Where are some that we already used all of them up? Like here, we used all the X's in that line. So if we had sandwiches or stuff, we would get extra clues. Let's see if there's any other cases of that. Oh yeah, here's 2 X's in a row. That would then have to be an O or an I, but the I's are used up for that column. Okay, so now this right here can't be an I because that would be a 3 in a row. It could be an O or an X. Now, here would have to be an O or an... Okay, what about here? That can't be an O because we have 3 in its column, and it can't be an I because we have 3 there. This is almost just like Sudoku style. We can show that has to be an X. So then we get 1 more X and 1 more O, but I'm not sure where they are yet in that row. So what about the rest of this column? We get 1 more X and 2 more I's. That can't be an I. We used up all the O's, so that has to be an X. Now these have to be I's because we used up the other ones. Okay, so we're getting somewhere. This one used up all its X's. That must be an O, because it's 2 in a row of I's. Now we get 1 more O and 3 I's. We can't have 3 I's in a row, so we need that to be an I for sure. Now, what about here? We have 3 in a row, and we need 1 O and 2 I's. Not sure about those yet. This one was almost full, but we couldn't get it. How about this one down? Oh, these are all O's. We used up the X's and I's there. Okay. Here we almost used up the I's and we used up the O's, so we need 1 I and 2 X's in here. That one can't be the X because it has 3 there, so that has to be an I. These, therefore, have to be X's. Okay, now we've used up the X's here. That can't be an O either, so it's an I. That could be stuff. That can't be an O or an X. And how about up here now? If that's an I and that's an I, we get 1 more I and 1 more O. That can't be the I. Okay, so this is getting somewhere. Now we used up all the O's in there. We get, that can't be an I, it has to be an X because the I is there. This, wait, it could, I might have been messing this up. We need 3 I's, and I hope I didn't mess that up earlier. For a second I was thinking like, okay, there's 2 of them there. That means we can't have a third. But no, we need 3 to prevent another. So I hope I didn't mess that up earlier because I almost did right there. This one, though, it's true. 3 I's and 3... Oh, squirrel. He has a nut he's carrying. Okay. Now, 3 O's. It's funny. I'm like a weird meta version of a dog with the squirrels. The dogs are like, I must chase it. And I want to like document the squirrel to show you the chase-like mood. So, not like chasing it, but like to show you the excitement of the squirrel. I'm excited about the squirrels too, but I also want to like get the camera in the right zone. So, it's a new age dog chasing squirrel thing. Now here, we have 3 O's used up. What was that? Something just fell. That was weird. Okay. 3 I's and 3 O's are used up. That's got to be an X. Up here, 2 X's in a row and 3 I's in a line. O. All that's left is an X. All that's left is no. Okay, I think we're pretty close on this one unless I messed up some earlier stage. These would have to all be O's. But now I'm all paranoid that I messed up at some point the thing that I almost messed up a minute ago. I don't know. So this, let's see. Where's our next one we can solve? Here. No. How about, where's ones where lines of 3's? Oh, the squirrel's back. This one doesn't have a nut. I don't have a nut for you right now. I'm sorry. I need to get more of them. Okay, so here, where can we go? That one has its O's used up. It could be an... Okay, so this one needs 3 I's and 1 X in it. So, is there anywhere the X can't be? Can't be there because of the 3 in a row. That can't be an I, so that must be where the X is. Okay, now, down here we've used up our O's. This has used up the I's as well. Now here we want 1 X and 1 O between these. Now, this can't be O's because of the rows, and can't be I's because of that. This can't be an I because of that. Could be an O or an X. This can't be an I. Could it be an X? Maybe. Let's see. Let's go over here. That can't be an O because of the sandwich, and it can't be an X because of that. Let's go over here. That is all that's left is an O, and all that's left is an X. Now here we get one more X and one more O. I mean, one more X and one more I. That must be the X, that must be the I. Now, we've used up the I's, so these would all be O's and... No, they're not all O's. Delete, delete, delete. We've used up the I's, so these are all O's or X's. That one could have been an X. That can't be an O because of that, so that must be an X. That could be either, maybe. Well, down here, let's see. That can't be an I. Guess it could be an X. And so that's an I or an X. And... But wait, we used up the I. No, that's an O or an X. And that, I guess, is also an O or an X. And this is also an O or an X. And this is also an O or an X. We've used up almost all of our I's. I think that's the last I. Oh, this just helps us a lot. There we go. Sandwiches don't work, so that must be an O. That must be an X. That must be an O. And that must be an X. And I think we got it. I don't think oh, yeah. It even shows we got it. Cool. So, Trinox. I like it. I'm going to try a harder size of Trinox sometime. So, these are just the tip of the iceberg of puzzles. I think we're going to try one more. And the one more we're going to try is a new one he says he invented, which is... I was like, wait, he has one called Play? I don't remember that one. Which game's called Play? And it's like, oh no, this is to play the games. So, down here, let's try this one. Where these are both new, but we're trying the ones that he says is Star Battle meets chess. And he says, this puzzle, a Crazy Dad original, is a cross between Star Battle and the traditional 8 queens chess puzzle. Here's how the chess puzzle works. You have to arrange 8 queens on a chessboard so none of them are attacking each other. Now, queens are attacking anything in a line of any sort of it, a line that is horizontal, vertical, or 45 degrees diagonal also counts. There are multiple ways to do it, so the way to turn it into a puzzle with only one solution apparently is to combine it with Star Battle. Now, in these puzzles, the board's divided into 7 or 9 realms using thick lines. Within each realm lives a lone queen. Your job is to position one queen within each realm. These queens are peaceful and must not attack each other using chess rules. Therefore, each row, column, and diagonal may contain one queen at most. You'll find it easiest if you identify and mark where the queens can't go. I use little dots for this. Each volume is ordered by difficulty, with the easiest puzzles in book 1, la-di-da-di-da. So we want an easy-ish puzzle. He says, I recommend you start with book 1. If you find they're way too easy, skip ahead by 5 or 10 books. So here's what we're going to do. We'll do book 2. That sounds like a good compromise between if it was too easy, going to book 5 or 10, or maybe it won't be too easy. We'll do book 2. So, and we'll start with the smaller size. Okay. So, this is one of the ones we have to write on. So here is the puzzle we're going to do, number 1. And we have 7 zones in a 2-knot touch-like way, but it's 1-knot touch. And they also can't touch in diagonal lines. And we don't even have to make the rule about their neighbors can't touch because that's covered by the diagonal, vertical, and horizontal lines. So, what do we know? We can't have a queen there. I'll put a little X for where there's not. We can't have a queen there because that would eliminate all of those. So we must have a queen there. I'll put a big circle for where the queens are. Okay, so that's the only queen in that line. So we can eliminate a lot. Maybe book 2 will be too easy, or maybe I'm getting ahead of myself. I guess I do have a head start because it has a 2-not-touch-esque strategy. And the 2-not-touch parts, even though it's 1-not-touch, he actually makes 1-not-touches too. I thought it was a joke at first, but you do have to use actual strategy to solve a 1-not-touch. And there's 3-not-touch. Just wait till we try that sometime. So that leaves just that for this queen. Okay, this is taking a while. We're going to do it this way. Eliminated. 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 Okay, I hope this doesn't get too confusing. At least we know where the queens are. We'll put the queens really carefully, and then if their diagonals look weird, it's fine. So, what's left in this zone? Can't be those, because of these queens. This is one of those, but it actually can't be that either. So this needs one there. Okay. Now, this has one in one of these spots. This has one in one of these two. Since it's in one of these two, we know the line from there this way will get eliminated. We also know that either of these are impossible. Those two. Because either of these would attack them. So, what's left here in this line? We're left with not that much. So, this needs a queen either there or there. So, one of these two, which I'll put a little dot on those, one of those two is a queen. And one of these two is a queen. If one of those two is a queen, this can't be, because that attacks both of those. Now, what's left in this zone? A few things are left in this zone. How about over here? Well, let's see. We don't have to just look at which realms are shrinking. We can also look at other things like lines and columns. So, what is the next optimal strategy? I'm going to put the spots where queens could be, since it got complicated with these lines, as a little dot. And those are the remaining possibilities per region where they could be. And also, if we look at it a different direction per line, as in row or column. So these are left as the spots where we could maybe have our remaining queens. Now, what does this tell us? Here, it's one of these two, so it can't actually be that. That threatens both of them. And it's one of those two now, and that's covered with that. Here, it's one of these two. Here, it's one of these further apart too. Let's see. So yeah, this is new strategy I'm trying to think through. I'm not sure exactly what the optimal techniques here. And whoever asked what the problem is, it's like laying 8 or 7 queens on here, so each one's in a singular region, but none of them attack each other in a straight line. So, where can we go from here? I know there's some way we can solve this next bit. We know it's one of these two. And so it's the other one in that range is either one of those two or one of those two. How can we approach this next? Well, this has one of those. this is tricky. I'm not sure on the strategy exactly, partially because I drew this in a really confusing way. Like, I'm getting confused on what's going on with my drawing of this, but also just because brand new puzzles require you to sort of start your thinking from scratch. So one of those. Now, most of the regions have a lot of possibilities, so it's trickier. If we look at the bottom two, that could maybe help, because that is only two possibilities, and that is only two possibilities. And it can't be both of those. We need one of these. It seems like there could be multiple ways, but of course I know Crazy Dad. He's only going to... I mean, I don't personally know him, but I know how he designs the puzzles. There's only going to be one solution, so there should be a way to get it. Someone says, oh, yeah, that helps a lot. Add the last diagonal of the top queen. Wade suggested that, and that definitely is going to help a lot. That means this one is a queen. And that's going to help even more. It goes diagonal down through that. So this is a queen. And that goes up through there too. So this is a queen. And here all we have left is... Wait, did I mess this up? I messed it up somehow. I'm left with these two, which are touching. Something has gone wrong. Something's gone deeply wrong here. Okay, this is a brand new puzzle to me. I will try it again in my own time because I like the do not touch-ish nature of it. And after I've tried it again in my own time, I will return to puzzles another day. This is a theme that could be fun to do in some live streams in a recurring way. And I wanted to do a semi-mathematical one before our next stream. Maybe another unusual Wikipedia articles stream. So for now, I wanted to do something semi-mathy. Like I mentioned, I have a bunch of bonus videos that are filmed, shorts and one or two longer ones for this channel that I'm having tech issues with the exporting of to get the colors correct. So hopefully I'll get that fixed soon. In the meantime, I might wrap up this stream soon because it has been quite long. It's been over 3 hours. And wrapping this up, thanks to Crazy Dad and thanks to the guy who runs, or the people who run, mathisfun.com. We didn't do the Nerdle or the Cross Nerdle, but we'll try those another day. And I recommend trying some puzzles on your own if you're ever bored, especially if you already do hobbies like video gaming and stuff, which I don't even do much. This is a sort of video game-esque sort of thing that I believe trains the mind and the ability to create deductions and such. So many options here. So we'll come back to this another day, a few streams from now. Until then, hope you all are having a good day. Hope you all remember to have checked out my new super long episode, my longest edited project I've ever made, on my Combo Class channel, which is linked in the description. And I'm going to continue the next week or two turning this classroom into the way it needs to be for grade -3. And here there's a bit of chaos going on that you may not be used to. This was sitting on a whole different desk than you've seen. However, grade -3 will have many patterns from before and much newness. So one more episode, the finale will be coming, and a lot more bonus content. I'll be back with another stream before long. Thank you all for joining me in this one. And if you want to go back and catch some of the earlier puzzles, I will try and add timestamps soon to this so that there are markers of where certain things occurred. And finally, a special thanks to Wade Eberly and Bardley Richard, who left some donations during this stream. All right, I love you all.